Hello everybody. We waited a bit more for latecomers. Anyhow, now we are, I guess, nearly complete. Yeah, completely complete. Yeah. So we are starting the second day of our, say, introduction of pyLife, and I'm giving the word to Daniel now.
Okay, good morning from our side. Yeah, waiting for the weekend, but we have some hours right now and some times to have closer look to other features we provided with pyLife. And also if you have any questions about our further developments, maybe if you want to integrate pyLife in your framework, on your package, we can talk about that topic. And also if you have some requests later on collaboration, either with students or with yourself, then we can also have a discussion about this topic. Maybe one remark. So yesterday there was some wishes, first of all, regarding the finite element meshes. So we have prepared this one additional Jupyter notebook, which was failing yesterday. To show you that really shortly on an FE mesh, how we can calculate the local damage there. And then we have prepared an additional Jupyter notebook for handling of time series, have a look on the spectra of a time series, also to clean up time series, and also to make the rainfall calculation on it. And for that, we have a new status on the repository. And additionally, you have also to add some new packages to run the Jupyter notebooks also on your computer. You can see here the packages we have added. It's Tram, maybe you can remember from yesterday, but also we need this package is called TS Fresh, which is dealing with features of time series, which we need for time series calculation inside pyLife. What you can do, you can either just by hand activate your environment and install with pip install, for example, train VTK and so on, or you just can create a new environment. And that's described here. You go directly, maybe we can do it together right now. Just go directly to your working directory. You can see here, maybe for example, type in here CMD in the prompt. You will get a command line interface. And now you just have to copy this command line, which overrides or deletes first your existing environment and then creating a new one with all the packets we have added. It takes a while. So you can do it here. I don't want to do it right now because it would take maybe 10 minutes, something like that on my computer. And I had prepared it yesterday. Or what you also can do, just go back, type in CMD. For example, you can activate your existing environment. Oh. So now it should, and now you can with pip install install all the missing packages you have here, like tram-vtk, and just type in. Tram-vtk, vtk, and so on. That would be the second option. That means you have activated your existing environment and you're just adding the missing packages. Yeah, that is the preparation for today. And you have also, or if you have a look now on the use cases, you see one additional folder, but we have in this folder damage calculation, we have added a new Jupyter notebook. It's called damage calc FEM. We have a closer look in the next minutes. And we have here a new folder with a time series. That's something we go afterward. Okay, should we wait maybe 2 or 5 minutes that everybody can install the required packages? If you need help for that, just raise your hand and try to fix it on your computer. Let's go back. Yeah. Oh yeah, maybe you just or the new packages or the new environment. If you want to with this command you pip install and then the new packages. No, there are different one here. You have to install all of this. Or come on, all of this. But you just can type in with one comment. Yeah, you don't have to do it several times. Just type in pip install train vtk, then train vtf, and so on. Yeah, and then you just should able to install all at once. Maybe you can have also a but you can also copy it directly from the repository. Yeah, but you have installed all of them then, yeah? TreamVDK, Train, Beautify, PyVista, and so on. Yeah. Yeah. You can do it step by step or all at once.
Like I can write them all. Oh, I see what you mean. So
Yeah.
just write it.
Yeah. In one line. Or that takes maybe 10 minutes or 15 minutes. Yeah. And it takes also 10 up to 15 minutes. Yeah. Maybe in the meantime, I can highlight 2 additional, let's say, side topics, because we have to wait around 5 or 10 minutes until every environment is set up in the according way. So the first thing I like to highlight, because we are also involved in this project, is another open source repository, which is called, maybe I show it here, Torch Physics. You can find it also at Bosch Research. We have also use cases for linear elasticity, but also for nonlinear elasticity and also dynamics. And that is dealing with so-called physical informed neural networks, where you want to have, let's say, a hybrid approach, where you want to solve, for example, partial differential equations, PDEs, or also all kind of, let's say, physical equations you have. So the simplest way is the so-called physical informed neural networks, where you add, let's say, to the loss function your boundary and initial conditions, and also itself the PDE or ODE, of course. But you can do it also in different way. There are also other approaches like deep grids, where you show the weak formulation. There's also a so-called deep operator network, where you want to regress the operator. Could be, for example, Fourier operator, Laplace operator, but also a simple gradient operator. And that is a really academic, let's say, framework, developed together with colleagues from the University of Bremen. And it's, let's say, right now from the stars, you can see here on the right above side, one of the most used repositories at, from open source at Bosch. And it's worth to have a look at it. So if you want to do something, let's say more or less data-driven or with part of AI, you can have a deeper look on that. And there are a lot of different use cases we play with, from fluid dynamics up to tribology topics, but also for nonlinear dynamics, for example, to solve the nonlinear oscillator. Like, I don't know if you know, maybe, for example, the Duffing oscillator, where you can play around with nonlinearity. But also more industrial topics are solved with this approach. Maybe we can have a look on that. And the other one is, just for Jan, I mentioned yesterday that there are different approaches, some terms in German, but different approaches about, sorry? Okay, so I can do it in German. No, about non-proportional stresses, and we inside Bosch have developed a new approach. It's called Cohen-Levy for complex invariances of linear wavelet inferences, or long term, but it's, let's say, focus on this complex invariances, and that deals with a problem if you're using any equivalent stresses. And have a look on the frequency domain, and it's shown here only for this very simplified Farmises stresses that you see. For example, if you have for a 2D use case with 3 stresses, and you want to build up the equivalent stresses, and we will compare that also in the frequency domain, that you see you have here in the frequency domain parts in a frequency which in reality does not exist. That means you get, right now here you have all frequencies for 1 Hertz, at 1 Hertz. That means you cannot have, if you have any equivalent stresses for that, additional frequencies. It's an excitation that is mathematically and physically wrong. It's not possible. But with most of the equivalent stress approaches, you will see such situations that you add, let's say, with wrong assumptions, new frequency parts in your signal, which in reality does not occur. And this approach is dealing with that you have a, let's say, frequency equivalent stress, which describes the behavior much more better. And we have also shown in 2 papers that leads to much more better results, especially if you're dealing with vibration fatigue. Just so for
better.
Yeah, maybe we can also go to the details of the maybe one of the paper. Means more realistic in terms of that. The first thing is we are much more faster. We are much more faster than, for example, critical plane approaches, which takes a long of calculation time, and we get much more realistic results in terms to experiments, compared with experiments with, let's say, more or less traditional methods.
Okay, we have a new multi-excel student.
Yeah.
So we can test your criteria on our database.
Yeah, maybe later on I can share the link. Let's find one of it. Here it's explained maybe in that paper. And yeah, I will share the link. Maybe it's the easiest one. We can go through it, but the idea is that you have both in time domain and also in frequency domain, an equivalent stress signal. Yeah, that approach is not, let's say, on a final state. It's not finished. Yeah, it's more than an idea, and we are using that for different use cases inside Bosch. But we are really open to discuss it and to check it against other use cases. Just
Great.
to highlight that. Okay, so but now let's come back to pyLife. I don't know if everybody ready to open the different Jupyter notebooks. Pip failed. Let's have a look on it. Logic. Yeah, maybe. Do you have already streamed on? Or on none other window? The common window?
Yes, maybe state. It should not be there.
No. If not, maybe we can try to run it either.
No,
it should work.
I have it here.
Yeah, but I think it should work either. And with the under command line window, is there something open?
Reason be that I put it from prompt directly from command line,
Yeah.
not from Anaconda.
No, that should work either.
Sorry, what should I do? No?
Just try it out. Can I have? See pixel. Wait, let's do it that way. Yeah, there is an existing environment. We can activate that.
You have GPTs there.
Oh, sorry. Just have. Where's the backslash? Huh?
Use the normal slash.
This one? Okay, let's do that one. It works. Hopefully it works either. So
I'm not sure if this is really the new.
yeah,
command.
we have to check it out to run the notebook maybe.
How?
The Jupyter notebook, we can run it and try it. The only did you have downloaded the new notebooks?
Should be the new notebooks.
Yeah, there are new.
Went through-
Yeah, this one.
I
I
downloaded
just
this
yeah, of course we have added yesterday in the evening 2 additional ones.
in the use cases.
Yeah.
It should be here.
Okay. Okay. No, yeah, there are the new one, and we can try out. For example, let's open Visual Studio Code. Maybe there was some problems. Because we had still, or it was open, and here you can see we have this one. Maybe we can try it out. Otherwise, we have to close Visual Studio Code and run it again.
That's the easiest way.
Yeah, but we can check if damage calc FAM is running or not. Just let select the right kernel. Okay, that is works. And what is with the? Yeah, it works. You can. I think you are able to. Yeah, work with that. Okay. Okay. I see most of you are able to open it. Great. So yeah, I think the most important things we had discussed yesterday and showed you that it's able to read in finite element files. Maybe also run one remark from my side. Let's go to that one. Okay. So reading in finite element models. I don't know which software you are using, but we are mostly dealing with ANSYS. Yeah. With ANSYS, you have also in Python framework, it's called pyANSYS. And the promise of ANSYS is that you can do everything you are doing on a workbench, or with APDL, you can do also with pyANSYS. In practice, that does not work as good as they promise, but it makes you much more easier to read in finite element data, and I think also to write back to RST files. The documentation is quite good. You can go through it, have a deeper look, and also how maybe, for example, to read in RST files, either if you have harmonic analysis, just stress analysis, or whatever. You can also, they have an interface to these APDL scripts, and for, let's say, parameter simulations, or for design of experiments, it's really helpful to have a look on this pyANSYS option. So for our course, it's quite tricky because they are using still this Python 2 version. And for other FE servers, we do not have so much experiences. But what is always possible is to use this open format VMap. And just what we showed you yesterday was that we have here, let's see, read in this 2-notch beam VMap file. And we were calculating the Van Mises stresses. And then just applied that to the whole mesh and visualize it via this PyVista functionality. Yeah. With PyVista, you can also play here around to have a deeper look on it. It's not able to select one element or node, and unselect all others, for example, or just select one part or something like that. I don't know if there's a solution for that or will come in the near future. Maybe with pyANSYS, they will have also a solution that you can also visualize much more better finite element models. But for most use cases, I think it's also really helpful to have a deeper look where are the stresses located and so on, the highest stresses. Right. Okay, and then maybe you can also plot the damage if you like to, and have a deeper look. So that's a little, you can see here damage values, and you can also play around with that if you like to. That was the notebook we failed with yesterday, and you can try out using other FE models, for example, playing just around with it. Today in the morning, maybe we can have a look on time series and how to play with that. So on the, you can see here in Visual Studio Code, we have an additional folder that's called time series. And there's a Jupyter notebook, which we have, let's say 90% copied from a Jupyter notebook from the pyLife cookbook. If you go to pyLife documentation, you will find also this very similar notebook. Maybe we can go to it and I will show you. So here on cookbooks, let's say not cookbooks, it's or lifetime. Here, time series handling. I think it should be here. Hopefully. Oh no, yeah. Here we have this notebook. You can have a look on it, but we will go through it and have a deeper look on the different topics we want to address. Yeah, everybody can see it. So first step, we have to read in all the packages and libraries and functionality we need for that. So for example, we are reading in here a lot of pyLife functionality. For example, here the rainflow module and the rainfall class recorders. Also some plotting options. And with that, we can go to the here what we are doing is additionally reading in a so-called function called plot_rf, plotting rainflows. So plotting rainflows means we have to plot a 3D signal, and that needs let's say some lines of code, and we just packed all these lines of code in one functionality. That's all. That's the Jupyter notebook is not too large. Yeah.
If I want to have a look inside the plot_rf function or the helper functions, how can I do that?
Yeah, that's two options. First of all, I try, it should work. Let's do it that way. So in Visual Studio Code, if you have any function, just press F12, yeah, and then you go direct F12, Control 12, and you will find directly, or it goes directly to the function, which is described here. You can see here, or in this case, you also can directly open the function which is in the same directory as the Jupyter notebook. Not really. That's what I'm doing all the time in Emacs. When I just want to check what is the function doing, I jump there and then right back.
It's just about the question if there's also a shortcut to jump back to.
Yeah, it should be, but
probably, yeah. Yeah, we can. It's actually what's the shortcut to get to the command line? Because this is also quite handy if you don't know. There's this, it's Control P or something.
The command line.
Yeah.
Try it out.
Yeah, it's in Control P. Then you can type things in, and it will give you all the. Or is it?
No, that is just the command line.
Files. That's the files.
That's all you can looking for. But also, I think if you type, type in this one, and then you can select a lot of options at Visual Studio Code.
And there's also a shortcut that brings you to a command line, and then you can find all these commands and the shortcuts. That's really handy. Yeah, the problem is that I don't use VS Code, but okay. I'm sure there is, but we don't know.
There should be, but maybe you can find it on Google. Try.
How can I do that in a Jupyter notebook?
In Jupyter notebook, I don't know. I don't think it's.
So Visual Studio and F12.
Yeah.
Okay.
That's the option I'm using. So yeah. Okay. So let's load this functionality here. And what we're doing next is just defining 3 different time signals. The first time signal here, which we are defining, it's in white noise. The second one is in sine. And the third one you can see here, it's just in sine over random signal, so an SOR signal, just adding the white noise signal and the sine signal. It's just 3 different signals to play around and have a deeper look on it. And you can see also the difference, of course. It's the rain flow, but also in the frequency domain. And we are doing that, defining in pandas data frame here, and set with help of the NumPy functionality, this white noise, and also the here the sine function. If you have any questions regarding the sine functions, let's try it out. You should get directly information how the sine is defined at NumPy, and then you go through NumPy and find if you are interested in how it's defined. But okay, and now we can plot that. Let's do it. So you can see here that is a different kind of plotting as we have seen yesterday. So here we have this white noise signal as a sine. Of course, we have, I don't know, the frequency we have used, but you cannot see it here right now. And here's the sine of a random signal. And we are using for that matplotlib, which is really fast, but it's a static plot. You cannot zoom in or anything like that. The good thing on matplotlib that is directly connected to pandas. So here, for example, we have this signal where our time signal array, and we can directly plot it with one command. The other option to plot, just to show you, is with this plotly functionality. Here is plotted all 3 signals in one plot or one figure. We can zoom in to have a deeper look on it. So for example here, to see the sine function, but also to see the white noise, and also of course we can once click again to see also the sine of a random function. So they are the main 2 plotting options, and both have advantages and disadvantages. Sorry, need the microphone.
Just isn't it pandas thing that the matplotlib plot isn't interactive, because normally it is. If you use matplotlib yourself, I believe there is some interface.
You can try it out with plt.plot the data frame. I don't think so, but
because when I'm plotting anything with matplotlib, I believe you get some interactive session, definitely.
Maybe you have this option, but normally not, I think. Try it out. We can try it out if you want. Should we? Okay, let's try out the plot. Just okay. So we want to plot directly with matplotlib, therefore we just import the functionality of matplotlib and then plt.plot. And now we need the signal df dot values, for example. And let's try it. So it's not really interactive, I think. You just can save the plot here.
It depends on the type of plot you're having, because for example, 3 plot, there is the first option to
to rotate, and so there are some options. Yeah.
sorry.
No problem. So let's come on this line. Okay, that means right now we have just one data frame which consists of 2 different signals. And if you have a look, maybe also on this data frame, signal df, and you can see that we are using here as the index the time, and for every column we have the different time signal. Maybe one comment also to this time index. Pandas is providing also a real Unix time index, for example, yeah, or a delta time index, where you can resample your data automatically to merge your data to get informations about, let's say, influences of the week, of the day, or whatever. Right now we have just an, let's say, classical way, as you maybe also know from MATLAB and so on, to define the time via an array. But you have a lot of more pandas possibilities to define time signals. In the next step, what we want to do is to plot the PSD of the different signals. Of course, you can discuss if it makes sense to have a PSD of a sine signal, because sine is per default deterministic, and the white noise is stochastic. But we just want to highlight you that if that is working, if the signal is correct and everything else, and you can see here the 3 different signals where we have on the one side the white noise function, and here we have the sine, and the sine over random you cannot really see because it's most time, yeah, except the one frequency of the sine signal, like the white noise signal. We have this options, or let's say the more a wrapper inside pyLife to get directly an PSD as a data frame. SciPy stands for Scientific Python Computing, something like that. Provides different options to calculate the PSD. As a classical one is the Welch, I think it's called Welch algorithm. Yeah. And this is implemented in the backbone of this by SciPy, and we just have a wrapper because SciPy is giving back only an array, NumPy array of the frequency and the PSD signal, and we are calculating that one. Yeah, I think you can have also a look on it, or it's also described here. And you will get back this PSD data frame. Yeah, you can also plot that with Plotly, so that you can have a deeper look on the interesting frequency at 50 Hertz. Yeah, I don't know if it's so interesting to have a deeper look on that. So the next step would be we can filter our signal, and we have also here this options or this wrapper. It's called Butter bandpass for Butterworth filtering. SciPy is providing a huge range of different filters. Any filter you can not imagine, but which exists or state of the art, like Fourier filtering, and we are using here the bandpass filter functionality of SciPy, and most, let's say in 99% in the cases, the filter is also stable here. Sometimes you get problems, yeah, with this stabilization of some filtering, but that is nothing which belongs, let's say, to pyLife. That's something which belongs to the algorithm itself. Yeah, then maybe we can filter our signal directly, getting back the time signal, and you can see here how it works. That we have above 100 Hertz this filtered signal, and the next step, what we are doing here is, okay, right now in the first 3 signals we have, or you can imagine that the white noise excitation is coming, for example, from street vibrations or for wind turbines or whatever. The second signal, sine signal, could come from an engine, from eDrive, or from from an it could also come from, let's say, exhaust system, whatever. So with a deterministic excitation. And then we have here the combination, and that could be understood as a real measurement, something like that. And then if we have maybe some spiky data, so we added here artificially some spiky data into the signal. That cause we have very often that we have to clean up the signal in, let's say, more or less automatically way. And there's also one option in pyLife to do that, to clean up the signal. That is a functionality where you have a lot of options. Either you want to delete only the parts of the signal where you assume you have spikes or whatever, or you can keep it. Here the method is remove or keep it. You can define the feature on which feature of the signal you want, or what you are doing. Let's say, explain it that way. You are windowing the whole signal, calculating for every Windows. For every window, you are calculating some feature like the energy, the maximum value, the mean value, whatever you want, the standard derivation. And then you just remove all parts which are above a threshold. This is based on the so-called tsfresh library, another Python package. Maybe we can have a short look on it. So here's tsfresh, and we have implemented, let's say, this, or implemented the tsfresh functionality into pyLife and have added some additional functionality to make this also possible and plausible for mostly for acceleration signals, vibration signals, but also for stress signals. You can hear, maybe we can have a short look on this tsfresh functionality, where you get, let's say, windowed features from any time series. That is the purpose of tsfresh, and what we have done is implement that into pyLife, write a functionality which is dealing with the rolling window functionality, and also what is really important, that you have a connection between two, or if you have delete one section or one window, you need to delay, let's say, a good approximation of the two neighbored sections, that you have no spike or not too high gradients in the signal, if you connect two different signals together. So that is done here, so we can run it to clean the time series. And of course, if you want to have a deeper look on the method itself in the pure code, you can click, for example, on F12, and you get here the code of it, and can see in reality, and the original code, and see what we are doing there. Right, so now we have the signal cleaned once again. And now we want to start the rainflow algorithm. Regarding the rainflow algorithm, we have different options we can try out later on. We have these, let's say, more or less standard method, which is described in the FKM or by the FKM. And maybe we can highlight also these, so I don't know if you should name it 4-point enhanced, but that's a 4-point algorithm. Maybe we can have later on a deeper look on it. I just defined in the end the bins, and the rainflow calculation in pyLife works, let's say, a little bit different as you maybe assume, or as you can see from other rainflow methods and algorithm implemented in commercial software. In commercial software, classical way is you get or you read in some time series and you get out the rainflow classes. You can plot it, whatever, have a look on it. Here we do it in two ways. The first step is to have a so-called recorder for a time series. And the second step is we, let's say, process the recorded value with a so-called detector. Oh, sorry. Yeah, maybe, but do you want to explain it more in detail? Because Johannes had written the code. He should know it much more better than I.
Yeah, the thing
Sorry,
about the detector and the recorder is that we needed some flexibility. So at first we had, as Daniel said, a classical rainflow counter. So what it was doing, it was looking for the hysteresis loops, and then it just made a list of all the hysteresis loops that it had found. And then this turned out to be a little bit unflexible in two directions. There was one group who said, we don't actually want to record all the hysteresis loops. We just want to classify them and count them because we have huge data sets, huge time series. If we remember all of them, that takes a lot of memory. And we, they had the idea to run it on a small device during measurements. I think they have never done it in the end. But they wanted to just classify them and right away forget about them. And so that was the one direction. And then there were other groups who said, okay, we want to also take into account not only the hysteresis loop itself, but also the temperature that was current when this hysteresis occurred, because that influences the damage, and we have a model to take that into account. So we also want to know the temperature for each hysteresis loop, or maybe the dwell time, and maybe other parameters. And so it turned out that we need to be more flexible. And so we separated the two things. We have the detectors. We have several detectors that just find the hysteresis loops. And then we have recorders that get a message from the detector. Here is the hysteresis loop. And then the recorder can decide what to do. If it wants to memorize I don't know what, the temperature or whatever it wants, or if it just wants to classify and then forget about the hysteresis loop itself. That's why we have the two separated. And what happens here, that's why actually Daniel mixed the sequence up. You have to, first we instantiate the recorder, because the detector needs to get the recorder injected. That's called dependency injection. Because once you instantiate the detector, you need to tell it this is the recorder you are supposed to report to, and that's why you have to instantiate them first. And we are from the beginning we are thinking about just making a default here, so that you don't have to do that every time. But yeah, maybe. Okay. Questions about that?
Okay, and then we just process our data. That means for every time signal, we are doing this rainflow calculation. And then we have different options. And what we want to have is, let's say, the 3D histogram, with the from, to's, and the cycles of every time signal. So let's do it. And now we can plot with the help of this plotting function our rainflows. And it's clear that you have here, for example, the white noise, a classical white noise, a rainflow. And maybe you can have also a look from the top, then you will see the distribution of it. Then we have the, of course, the sine with only one amplitude. and we have the sinorandom and the spiky values.
Just a question here is one version of rainflow matrix with from two axes. Have you also amplitude, mean values, or something?
We have
other
it, you can
implemented?
get it, and we can also plot it, of course. There are both options. Yeah. So, for example, let's check. Yeah. I think we will say later on if we are calculating the mean stress, then we can have a look on that. The mean stress transformation.
And there is one more question concerning rainflow. What is the residue treatment?
The residuum?
Hmm.
Okay. Yeah, that is a really good discussion. Yep. So what arises very often, we had the problem, for example, there's one count is missing or one hysteresis, yeah, and we have stored all the residuums. You can plot it, or you can also see it, yeah. And if you want, you can add it right now manually, yeah. But we are in discussion to make, let's say, a default function to add the residuums in the end to the, let's say, to the rainflow histogram. But that is, let's say, there are options, and both of it you can discuss. I think there's no, let's say, one decision to make it. Yeah. So maybe we have to clarify it more in the documentation how to deal with residuums.
Well, yeah.
But,
before we clarify this in the documentation, there is one discussion point in our discussion panel about that. It's because we had several issues who just addressed this, and they said there's something wrong with the rainflow counter. Also, from internal, we received reports that there was confusion about the residuals, and then for an upcoming rainflow counter or rainflow detector recorder combination about the FKM nonlinear, which takes also into account the strain hysteresis. So that's a little bit more complicated. This also has exactly this issue of in a little bit more severe way. And so we in the next months want to take a decision, because we then need to fix the API. And so if you're interested in that, then find this discussion in our discussion panel, and then probably in January, February, we will raise this again, and we will try to come to a final decision, which is not that confusing.
So you have everything stored, the residuals, but they are right now, they are not included in the histogram.
And I think I'm not actually exactly sure if this is mathematically true, but one trick I thought that that might be also an interesting option is just to process the residuals again. If you show the detector the residuals again, then they should be all closed.
Yeah, that's something which is implemented in practice directly that way, because of there are very different versions of rainflow counting. I think this is the 4-point method, and yeah, they are running the rainflowing the residuum second time, which closes all cycles, and which is more conservative, because of you are expecting that this is some cutout of your complete process, loading the structure all the time, again and again. So technically, there should not be any residuum except the very short start and the end, and all residua in between should be counted as full cycles.
Yeah, yeah. It depends on the length of the signal, of course. Yeah, of course, you can also, let's say, combine different signals or together. Here we just combining the rainflow histograms. You can see here if you add the add different signals, for example, and you just can play around. It's nothing special. In the end, you can also combine PSDs. Combining PSDs here, for example, use the envelope, the max value of every PSD. You can see here, that's also an option you can play around with. And yeah, finally, we just saving the rainflow calculation because we have another Jupyter notebook where we use this rainflow matrices to calculate the damage in the end. And we just want to do double work, yeah, just using this already calculated rainflows to use that. Maybe I'm thinking if you are interested more in this residuals topics and so on, maybe can also have another notebook to show you that you can plot it, see it, visualize it. But let's say more or less traditional, yeah, just type in, I think the command is .residuals, something like that. And then you get it. Maybe we can also plot it here. Just
there was
try it out.
there was a comment in the chat that also replaying the residuals is a standard way in ASTM, and this is something that I've been thinking of that the recorder should have another method like close residuals or replay residuals, and then it just plays to the recorder the residuals again. I think that would be quite convenient.
Let's do it. Okay. That was a short introduction to this rainflow calculation or time series handling. Let's say there's a lot of other packages which are dealing with time series or with signals. Especially at SciPy, there are a lot of functionalities. There are a lot of functionalities you can do directly with pandas on time series. You have a wide range of options to dealing with vibration data, especially in the frequency domain, building up cross spectra, transfer functions, build up a state space system, and so on. Everything is possible, but that is not a specific pyLife functionality. That is more regarding time series. There are also existing different rainflow methods coded in Python. We have coded our own one. We have tested it with a lot of test cases. Also with a lot of internal, let's say, practical test cases from different internal customers. And yeah, let's say we would trust our implemented rainflow algorithms. Yeah, the next step would be then the mean stress transformation using, for example, an Hay diagram, to then get the load collectives or load spectra, and to make then the damage calculation works. Yeah. Do you want to learn more about time series or rainflow? I don't know. Or it's enough for the first introduction of it. So the main topic is you can use the rainflow calculation, can use different methods. You get everything. You get the cycles, you get the hysteresis, and you get the residuals, and you get it as in pandas data frame. So here you can see it as an index. We have this from and to index, but you can transform that also to an mean and range index, that you get also the amplitudes of it.
Maybe just to clarify this. So this is we also had it yesterday that these pandas data frames, they use this concept of index a lot. So they have this is actually not a data frame. This is a series.
Yeah.
It's a little bit confusing because you say you would think a rainflow matrix is something two-dimensional. So why do we have actually only one column? But we have two indexes. We have one. So the multidimensionality comes from the two indexes, and that's called a multi-index. So these indexes can have different types. Usually they are just integer numbers. They can also be strings. They can also be float numbers. And this is quite interesting. That's an interval index. So that's it's an open interval limit here and a closed interval limit here. And so this is quite convenient to store any kinds of histograms. So yeah, when you see
how can we plot the amplitudes of it? I think we had to add collectives, or
yeah, you can access this with the load collective accessor, and then you get the amplitudes.
The load collective,
and then you can say amplitude.
I think right, and now you should get the amplitude, for example, of every,
yes,
so from 2, and maybe you can calculate it by yourself.
And that's also interesting because there is you can also modify this. You can also, that's also a discussion that we had quite often with colleagues when you.
Maybe just one question topic. Here you can see all the functionality we have. Yeah, with this load collectives, you can get the error ratio, for example, if you want to. And there are a lot of different options, yeah. So let's try it out. I don't know what you want to have, cycles or yeah, that's really interesting. Also the scale and shift options. So for example, if you want to scale your data frame with some parameters, you can scale it or you can shift it to a different range.
Yeah, that's what we have done yesterday. We scaled it to the global load. And you can also shift it. That's interesting when you have in your FEM model 2 stages. One for the assembly load. When you have a static assembly load, then you can shift it by the assembly load, and then you can actually modify these load collectives for every node. That's quite flexible.
Let's do it that way. So for example, now we have scaled it. But we can also shift that. Should also work. So now we have just shifted, by this value of 10.
But there's can you show the amplitudes again? So Daniel, you said we could calculate ourselves, and then the interesting question is how do we calculate these? So this 3 here, that's the difference between 120 and 1. It's a little bit because you have these 2 limits here, and what's the actual amplitude? And this is also something that people at Bosch do differently. Some use the left border of the interval, some the right one, because it's conservative. Some want to use the mean. And we have, I actually don't know what our default is here, but in the load collective, you can modify the load collective behavior here. I think it's
directly here.
Yeah, when you yeah, I think it's. I'm not sure what the.
Let's try.
Use class left, use class right. Yeah.
And we can try it out.
And then amplitude. Yeah, I see. We need type hintings to get these completions. No, amplitudes with it's
really
maybe a marginal difference, but yeah, you have to be aware of that when you calculate the amplitude.
This one, we can try it out. Is this is the functional? Yeah, you.
Yeah, that's then a one-dimensional histogram.
Only with the amplitudes. Yeah.
Only the amplitude. What you can also do, you can mean stress transform it. We have a mean stress transforming module, and then you can give it a Hay diagram, and then you also end up with you can transform it to a target R level, a target R ratio. That's because that's the usual task that we have, and then you actually end up with again with a two-dimensional histogram, but they are all on one line on the R-1 line.
Okay.
And all this, there is maybe you can show this notebook where we have the whole chain to the damage calculation, because that's we have that in pyLife. Yeah. We have actually two notebooks, one which does the rainflow calculation, and one which then uses the rainflow data to actually do the damage calculation. I think it's
this one.
Yeah. Yeah, at that point here, we actually read the rainflow dictionary that we've just made, and then here we do the mean stress transformation.
Maybe we can do it. Just copy and paste it directly. Mean stress. We need, I think, this one. Just adding. So how are we doing that? Read in some mean stress parameters. And now we can let's try that out. Okay, and now we can have a look on it. So, okay, now you can see here the transformed, only from the white noise signal, the transformed amplitude.
And I think this is probably also a little bit reduced. It's only the ones that are non-zero, something like that. Yeah. Can you go back to the line how we did it?
Here.
Yeah. Yeah, so this is how we do it. You set up a series which describes the mean stress sensitivity. We have this FKM Goodman mean stress transformer. Hay diagram. You can also use a completely manually set up Hay diagram with arbitrary sections. That's also possible. And then the deciding thing is you have to give it a goal R value where you want to transform to. And then, so these are all the ranges for with the transform to the R ratio -1.
Yeah. I know we have this 5-segment Hay diagram, I think.
Yeah, I think 5-segment, we do have a 5-segment, but they are, finally they are using all the arbitrary ones. It's just for convenience. We have a couple of functions who create them.
Okay. The cycles, you want to have it, or? Yeah, and that is cycles, right? Yeah. Further questions or wishes regarding time series rainflow
Yes, and this collective you can then map on a FEM mesh and then calculate the damage for every node. That's possible, and that's actually what we do in the notebook. Daniel has copied the code for. When you go down in this notebook, then you see how we do that.
Here. I think that's here.
Yeah, then we end up with there's only a couple of elements actually
which have
in
really
danger.
damage here. Okay.
All right. Any more questions about this time series handling, rainflow counting, ideas?
Yeah, feel free to join the discussion on GitHub. Yeah.
Yeah, I actually
Write
posted
a comment.
posted the link to the discussion in the Zoom chat. I don't know how you guys get this then. But it's just look at the discussion board. It's one of the. It's easy to find.
Okay. Then I would propose to make 15 minutes pause, break. And yeah, see you later on 10:30 or okay. Up to you how we want to proceed. It's on. Now it should work. Okay, now it's up to you, to the audience. Yeah, how we want to proceed. We have different options. We can go through different Jupyter notebooks, but I think you now already how to work with Jupyter notebooks, how to change Jupyter notebooks, how to add some new modules on it, and so on. So I don't know if it makes sense to go to 5 other Jupyter notebooks we have prepared. You can download everything or all the Jupyter notebooks from the pyLife Git repository directly. Have a deeper look on it. There are also Jupyter notebooks regarding the FKM nonlinear guideline, for example, or I think also for the FKM linear. I'm not sure right now. But there are also a lot of how to dealing with meshes, with collectives, and so on.
First was during the coffee break was to show how to read ODB files, and so yes, one thing that I have a little bit underestimated when we actually fixed the or when we had fixed the time of this event, I said, okay, that's actually near Christmas, and I will take the night train to Bratislava, and then I did not bring my Bosch computer, but only my private computer. And with my private computer, I actually cannot even access the pyLife repo properly. It's a little bit. I actually wanted to fix something yesterday. It's not possible. And another thing is, I don't have access to an Abacus installation from my private computer, and Daniel isn't using Abacus, so he doesn't have a license assigned, and so we cannot show it live unless some of you guys is volunteering or has access to an Abacus license. But what we can do anyway is we can show how it would work in principle. And yeah, so maybe I will just show in the documentation.
So it's okay for you if you go deeper into this topic. If you have
we can show it. We can show it quickly.
Just write in the chat and
good
news.
Okay, maybe
so let's try it out with the license.
Yeah, maybe I will just a little bit explain how it works, because it's also a little bit risky, because we have to set up some things. So we have here in the you see in the documentation we have the pyLife add-ons. These are separate packages. There's the ODB. Where's it gone now? pyLife add-ons. Yes, there's the ODB client and the ODB server package. And the thing is about Abacus, Abacus comes with its own Python engine. And the current versions of Abacus come with a real ancient Python version, Python 2.7, which is actually deprecated since I think 2012 or something. And it's actually end of life until from 2020 or something like that. So you're not supposed to use it anymore. And so for pyLife, we definitely cannot use it because we want to use all the Python 3 language features. And that's why we made, yeah, it's a kind of hack. We made a client server architecture, so to speak. We have a Python package which is called pyLife ODB server, which you can install into a Python 2 environment. And then you can install pyLife ODB client in a Python 3 environment. And then when you set up everything correctly, as described in the documentation here, then what you can do is you can just transparently use ODB client to access an ODB file, and then you can use it like this. You have here, you import the ODB client, you give it some ODB file, and then you can get the data out like the instance names, coordinates of an instance name, and yeah, step name, frame IDs, variable names, and then finally also variables. So that's the variable of a certain instance, of a certain step, of a certain frame. And then you get these. Remember yesterday we talked about this mesh data frame structure, and you get this in the exact structure that you can then later use to do operations with the pyLife functions. Yeah, and that's yeah. You can also take several variables like the stress and the strain, and then you can join them together. Also here we have only the variables, so we don't have the coordinates, and we can join everything together. So we can take the coordinates that we have taken here, we can join the stresses, and we can join the strain, and then we get a data frame which has everything. Does everybody know what this join operation is? Might I explain it? It's so a join operation is well, think about you have a table, and in the table you have I don't know, in one column of the table there's names of persons, and then you have another and I don't know, street and whatever, and then in the other table you have also the names of the persons, and then you just join these two tables to one table just by, yeah, you have for each person you look, okay, what are the lines in the other table of this person, and then you make a joint table of that. And that's what this join operation here, that's a standard database operation. This is pandas can do that, and they have quite a performant implementation of that. So, and we use this to actually we have this here. This is what the node table looks like. It has only the node ID here as an index, and this is what the stress table looks like. It has node ID and element ID, and then we join them together. Then so then here is the coordinates joined in. Yeah. Then we also have yeah, that's quite important. We have the element connectivity. So you get back a pandas data frame where we have for every element a list of node IDs that are participating in this element. And you can, there's a couple of other functions. You can get the list of element IDs of element sets, so element set names. And then you can also restrict everything that you do here. You can restrict to an element set. Where's the for example, no, where's the, okay, so here's the element set. So you can get the element set names. You can, instant names, node coordinates we have seen. Node, same for the nodes, the node IDs. You can get the node set names. And here variables you can restrict to a certain element set or a certain node set. So if you are only interested in a certain node set or an element set, you can restrict that here. Yeah, and that's how to access the ODB files. And yes, so that's that's how you would do it. I'm not sure if we want to actually try it out on some installation, because what's difficult is you need to set up this server environment, and that can be quite tricky, because you need to if you do it like in the documentation, it should actually work. But it's if you have a standard, fairly standard Abacus installation. At Bosch, we also have HPC clusters. That's more tricky, because it's not that clear where the Abacus binaries reside, and so you have to hack your way through that. But usually, what you would do is you would create a Python 2.7 environment and install the pyLife ODB server. And if you name that ODB server, this environment, then it should actually work out of the box when or if Abacus is in your execution path. That's actually what you need to do.
There is one question from the online audience. Can we get element coordinate system?
The element coordinate system, you can get what's in there. It's I'm not sure what they actually mean.
You have different coordinate systems for nodes, for elements, and so on. For example, for shells, it can be important.
Okay, no, you cannot get it as of now, but it's something that we can. If there's an Python, if the Python interface of Abacus allows it, then it's should be quite easy to get it. It's this was actually also written in this typical open source way. We just implemented what we needed for a certain application, and then it was also quite an interesting history. Because we can now in the latest version we can also get the history output. That's also something that we in our department have not needed. And then someone inside Bosch said, "Okay, I need the history output." And then we said, "Okay, we cannot do it on our own, but if you find someone who does it, then we are happy to collaborate." And then he actually found someone inside Bosch who he could give the task to do it, and then we had this inside Bosch, this open source model already works. So if anyone is interested in implementing that, then yeah, we are happy to supervise. Just file an issue, and then we can actually start in January. It shouldn't be too hard. All right. So that's about. Maxime? Does it answer your question more or less? Is it what you wanted to see? Yeah, we could try. Yeah, if anyone has an Abacus installation here, and also a Python setup, an Conda setup, we can try it.
So this is an open request because of it seems that the installation process can get a bit disrupted. It can take some time, if I understand it well. So
Yeah,
is there anybody willing to try it on his computer?
Yeah, we can also set it up somewhere during you are doing different things. It depends if everyone wants to see it fail. Yes. Okay. Okay. Yeah. So then, if you're successful in setting it up, we can try it out. I can also help you while Daniel is doing something else. But maybe in the meantime, we can select some topics that we can use for that we can do during the rest of the day. So I have a couple of suggestions. There's one interesting thing about actually what's in pyLife under the hood, the data model of pyLife, because for example, a damage calculation, calculating a damage value, it's from a mathematical point of view, it's not that difficult. You just actually compare stress and strength and build a ratio. What's actually interesting or what's difficult is you need to do that for a mesh or with a load collective, and you need it's the data handling which is interesting. And as I also said yesterday, why we have separated this mesh and the stress module or sub-package, it's because when we are dealing with the strength and fatigue models and stuff, then we don't want to concentrate on load collectives. We don't want to concentrate on meshes. We just want to focus on the damage values as if it was only one node. And then we have under the hood of pyLife, we have this broadcasting mechanism that then does the upscaling. And that's something we could also show how it looks under the hood, because that's also quite useful maybe for other purposes. And that's one thing that we could do. Maybe we can also could show how test-driven development works. That's a little bit also depends if the colleague is answering. Oh yeah. Okay, he's answering. He doesn't have the presentation, but maybe he has the code repo. Yeah. Okay, he has a video. Okay. Yeah, so that's something that we maybe can do. That we might do also in the afternoon, and then other options or other wishes. What are there some wishes that you would like to see, would like to discuss, to ask?
I would just mention that Benoit Delettre is writing us that there is already a Python package that do it, I guess. That's for getting the ODB. And he writes, and the 2024 release will accept Python 3. I mean, I guess this is a release of Abacus.
Yes, that's true. That's also what we heard, that the most recent Abacus release finally comes with the Python 3 installation. So the thing is, we did not have maybe we had the rollout of it at Bosch just now, I'm not sure. I did not have it in my hands yet, so that's why we have not made use of that as of yet. And we are not actually decided if we will stick to this client server model. It will depend a little bit also how restrictive Abacus is with respect to the actual Python version, because it happens really often that this only works with Python version x.y.z for some reason, and then if Abacus also says ours is working only with A point, B point, C, then you all of a sudden have a not solvable conflict, and that's the advantage of the of this client-server architecture, because then at least the abacus requirements are out of the way, and they, in our experience, are quite annoying usually. And so we will see how it develops in the future. So maybe we will at some point throw away this client-server architecture. All right, question?
More like a suggestion for what we can have a look into.
Yes, sure.
In category of
Is
strength.
the microphone on? Okay.
It's on. In pyLife web pages, I've seen in category strength there is a failure probability topic. So maybe we can have a look into that if everybody agreed.
It's there was a suggestion to take a look at the failure probability module. This is actually quite you can just browse there. This is quite a simple. This was one of the first modules that we had in the pyLife library. Where is it? Reference. Okay. So we will have to see if we can access later on. So strength, failure probability. Yeah. So this is this. Is there only this little documentation? They should be. Oh, this is again some weakness in the distribution, in the documentation. So we have these. This I wonder why there's the members are not documented. So what this failure probability class is doing. Do I have pyLife here somewhere? So we have to look at the code. What this failure probability class is doing, here it is. This is actually how this documentation works. You see, there's in the code there is this doc string here, and this is written in a certain syntax. It's the NumPy syntax, and this later on in the documentation looks like this. So this is the same text here, nicely formatted, and usually it should also. I'm actually wondering why these don't show up here, because actually also these doc strings should appear here, but they don't. That's maybe in the. By the way, you can switch between pyLife versions. So latest is the one that's actually not yet released. Stable is the latest released one, which is the identical to 2.210, and then these are the older ones. Here it's also not. Let's check out even older ones. Okay, here it has the. Oh, I need to look into this. So this is no. It also doesn't have it. It just looks differently. Here we have it. So I don't know why it's not in the newest version. I need to look into that. So so this is what the so what we are doing in this failure probability. We have a strength distribution and a stress distribution.
Just we are a bit struggling because of we wanted to get into the screen the information from the chat, because of there is the link to the ODB package which should work in Python, how to deal with that. Maybe we will get it there. And second, when I'm interrupting that, there is a question from Stipica Nevoselats. Is it possible to extract structural hotspot stress for weld fatigue? As I understand it, there is not yet that possibility, but thinking more about future development. Difficulty with it is due to the FE modeling requirement for node distance from weld edge and doing the stress extrapolation, which is used for damage calculation. That's something what also Bas was discussing here yesterday. All the processing of weld analysis due to this coexistence of requirements to deal with the mesh, with nodes position, extrapolation, and so on. That's really something quite demanding. So I myself would propose Stipica, program it there and we will have it there.
Maybe then to avoid to run into confusion, maybe let's separate the different topics, yeah? Okay, so let's maybe just finishing the failure probability issue, yeah? And then see how much time we have left. Then we can go to the ODB reader topic. And after that, we are really open to discuss feature requests and the future development of pyLife. And therefore, of course, it's an open source project. That means everybody can collaborate on it, work with it, can discuss it. And but let's do it, let's say, after finishing, let's say, the technical topics of pyLife. It's okay. That way, yeah? Okay. So, yeah. But do you have something where we can draw, let's say, some curves on it? Not? But maybe we can show it on the Jupyter notebooks.
Yeah, it's
No problem at all.
We would have to we would have to set it up a Jupyter notebook. I don't know if we don't have a demo. Okay. Ah ja, okay. Dann I can nur das Bild oder wie das? Ja, okay. Ja, okay. Dann such das mal. Geh mal in ein neues Fenster, dass ich dann das wieder zurückfinde. Ja. Yes, here. First this one. Yeah. So this is. Okay. Maybe this will work. All right. So you have actually two distributions. You have one strength distribution. That's the blue curve here, which will then be actually a Gaussian distribution. Yeah. And then you have here we have only one load, so we don't have any scatter in the load, and then we can do a is it a folding? It's a little bit debated what the mathematical operation is. Here it's just the area. A convolution, yeah, the convolution. So here the convolution is simpler. So here we have only a simple load, and we can calculate the damage, the failure probability. So it's basically it's the area under the blue curve up to this point here.
The problem is you cannot see it really, so you have a really low failure probability in this case.
Yeah, it's a low failure probability. If you increase the damage to here, then it will go.
In general, in the most automotive use case, you need 1 ppm. It's dealing with lower failure probability as we have seen here. Maybe one remark on that side. So very often in the development, you have the scatter of the materials, because you had your Wöhler curve and you have your scatter and the cycling and in the load direction. But it's really hard to get the scatter from a field distribution of the loads. So you can do it, you can assume something, but mostly that is deterministic here on the left side. The black curve. If you have it, you get much more realistic failure probabilities. But for that, you normally use needs user data, user loads, and so on. Yeah. And of course, if you have, for example, excitations for wind turbines coming from wind or storm or whatever, then you have an indication of the scatter also on the left side. But if you have just profiles coming from the OEM or whatever, you don't have this information. But if you have it, you can make here the failure probability much more realistic.
Yeah. So then it's actually both are a distribution, and then well, many people would actually draw this this area here, but it's not entirely correct. It's
let's see or convolution of both functions. That means you move the blue function over the red one, and everything underneath. Let's say. How do we explain convolution?
Yes,
it's a multiplication and frequency domain. Let's say it this way. But no, it's let's say you move both the one function over the other, and everything underneath this movement, you can integrate it then. It's the failure probability.
Exactly, and that's what we can do with this failure probability model. This was actually one of the first modules that we had that entered pyLife, and this well, you have a class, the failure probability class, that you would instantiate with the strength data. So this is also this is the strength median and the strength standard deviation. So this is actually the data that describes the blue curve as a Gaussian curve, and then you can use that to calculate failure probabilities. Or maybe we can do it in a Jupyter notebook. Do you have a Jupyter server running here, or? Oh, first we look at it, and then you basically have three functions. So this is the function for a simple load. Sorry. So this was the picture here. So if you have a simple load, just one constant, one non-scattering load value, then you can use this simple load to get the failure probability. And so this can also be several loads. You can put in a whole FEM mesh here if you want, with amplitudes or something. So with amplitude values, and then you get the failure probability for every node, for example. And so that's the simple load. Another one is you can have a normally distributed load. Then you have to have the load median and the load the standard deviation. So this is basically the description of the red curve, and then it calculates the failure probability. You can also have a limit here, so you can say, okay, everything under or over a certain load I'm not interested in. That's I actually have forgotten why we did that. That was some of our internal customers was using that because they were ignoring some loads for some reason. Yeah, I think they had something like they had a certain load, or I don't know. This was something that we needed for as a special request from some of our users. And then the third function is you can just put in an arbitrary load data. You have the load value and the probability function of the probability sensitive for this the PDF for this load. And then so if you have this, if you don't have median and standard deviation of your load, but you have already a measured distribution, you can put that in here. And this is also something. This is something, as I said, it was the first one of the first modules that we had in pyLife back in 2018 or something, and then we never touched it again, and so that's why this is still in the little bit old-fashioned style. So it doesn't actually use these fancy pandas data frame setup. So that's also might be also something that we could put some work into to get this a little bit more in the more convenient. But that's what the failure probability module is doing. Basically, this convolution of the load distribution and the of the stress distribution and the strength distribution. Does this answer the question? Or follow-up question?
Just a quick one. Have you said since 2008?
18.
18. Okay.
Yeah.
So you are developing pyLife for 5 years now.
Yeah, well, it's maybe a little bit of history. It was we are developing. I think we started in 2014. We started to actually have the courage to deliver software to our customers. Before it was we had this. We were only in this exploratory manner, and then. We said, okay, we now certain things can actually roll out. And then we, in the beginning, we used the software that we already mentioned, Encode, which does also already quite a lot of things. And it has a Python interface, and we just wrote plugins for Python, for Encode. And then we said, okay, not everyone wants to use Encode for many reasons. It's expensive, and they maybe have other solutions. So Bosch is a big company, and so we have a variety of tool chains. And so we said, okay, we need to collect this somewhere else, all these methods. So let's make a library to collect all these mathematics that you need to do all these things. And that was, I think, 2017, 18, somewhere at that point. And then we said, okay, we want to have a low barrier for people to use that, to try it out, not to actually use that in production, but to look at it, to try it out, to invent new things, to play around with it. And then once somebody comes up with a good idea, we can actually stabilize it and roll it out to production eventually. And then we said, okay, that's we have this this notion of inner source at Bosch. This is what many companies have. Also, Daimler has it. So many bigger companies do that. That they have like an open source culture inside the company. And there's also a special license for that. And so you can just distribute software inside the company, and everyone inside the company is allowed to use it. And we have this open source way of collaborating. And then we said, okay, we will do this inner source. But then we said, okay, if we are only collecting state of the art, we can actually open source it. And then that was the decision that we open sourced it. And I think this was back in well, we had pyLife inner source for I think a year or two. Then we decided to open source it, and then we had to go through the process, which at that time was not that streamlined. So it also took a couple of months, and then I think the first open source push was in 2019 or something like that. Yeah, and yeah, that's more or less the history. And that's also that. What's also interesting here, this version 1.1.4, this pyLife 1. This was really a little bit different from what pyLife is today. It was really a collection of independent things. So it was we just put stuff in, and it did not really work together that well. And that's something that we actually tackled for pyLife 2, that we have data structures that actually work together well. We have not done this for this model yet that well.
Can I have a question?
Mhm.
Concerning the load variable? Because when I'm teaching that students, as you told that it's very simple to get a probability function for the material, but where to find the probability for the load? Yeah.
Yes.
Is there something implemented in pyLife or?
No, well, how to find it?
No, better how to compute it.
Yeah, how to compute it? Well, what do you mean? What we there's in pyLife we don't have anything about that. It's a little bit the question in general how you would obtain it. So well, we have maybe we can ask Daniel about it because he's the one who's more has more been into that. We have a whole project about getting load distributions. That's an internal project, and that's really we put a lot of effort in. Then there is, of course, the test drivers who are driving a defined route over and over again to produce load data. And yeah, Daniel, about the question how to obtain the load distribution. In principle, that's something that you could talk for 2 weeks or something. Yeah, yeah.
Yeah, so there are different approaches on it. So sometimes you get from your customer or internal, let's say, some kind of estimation how the load is gathered. And the question is always, what is the load? Yeah, you can say, for example, if you have forces come, or let's say, or moments coming, for example, from an engine, yeah, and you want to derive stresses on some different nodes, then you can, for example, nodes in the end for stress calculation, because a local evaluation, you need always stresses to compare with the strength of the material. Right? And for example, you can do it in that, or you can estimate different driver behavior. So in the automotive world, you have very often this 95% driver. That means you have the 95% most critical driver. What means critical? Not based on velocity or speed, but how the driver behavior is. But if you, and mostly you get the load collective of this 95% driver. That means you have professional drivers who are driving in that way you want to have it. But you can also estimate if you have a 95% driver, you should know the distribution to get the 95%. Yeah? And then you could also estimate, let's see, the scattering of the, let's see, behavior of the driver, and with that of the forces, and with that, if you extract this to stresses with the stresses. That is not really common right now, and totally different approach is in my point of view, which is much more easier to implement and also get realistic statistics of it, is a data-driven approach. It means if you have the real, so also in terms of automotive driving behavior, but that could be also in production lines, for example, the real production behavior of some machines or whatever. Yeah? Then you can derive the differences between different drivers, and for example, in terms of vibration, but also in terms of forces, moments, or temperature, if the temperature is a load, for example. And with that, it is able to derive also the scatter, yeah, and the distribution of the different loads you have. And if you have that, then you can apply that to the failure probability approach and get, and that is the goal for all of, let's say, a lot of investigations we have right now, not only at Bosch, to get much more realistic load profiles. And much more realistic means always you don't want to have deterministic results. You want to have also an uncertainty quantification in the results. And for that, you need a lot of data, and you need the scattering of the data. Not only the scattering, but you need, that is one of the must-have you should consider. So there is no from my point of view, there's no one general rule how to get the scatter. It depends on the load, depends on the way to get the loads, depends also on the data you have. But yeah, but for the future, it depends only. You have a lot of data, you get different driver or different usage behavior, and based on that, you can extract the loads.
Does this answer the
that
question?
a little bit more?
All right. Then further topics. Yeah, I need to check why this is not rendering in this one here. Okay. All right. Anything more about failure probability? Okay, then
Should we go with the ODB server?
has the
proceed
ODB
with it?
server worked or?
Which I sent you yesterday for the second day, because of one of the colleagues sent there the Python library for ODB.
Okay, so what's the exact error message?
I was trying to run it as well in the router, and it told me that it's unable to find
Okay, here in the Jupyter. Okay, there's another error message. What does this mean here?
system is unable to find the given file.
So, are the paths here correct? Yeah, it's the thing with the slashes, but it's now the question of which file is actually it means. No, this is we cannot Python abacus, and then it's the executable. Just check if this here works. Oops, what's happened now? Okay, made an error with pasting. There's this D in the end. Okay, so this okay, so this is code, and now it's in bin. Yeah, we need the bin here probably. There's a bin. There's some slash missing here. Slash. No, where's the slash? Tell me what the slash is. The forward slash. Okay.
So for your information, one of our online participants sent us the link to this library in Python, which should deal with ODB as well. So that's here for you to copy the name.
What's this? Oh, it takes a while for some reason. So it's a little bit strange because usually this instantiation is quite quick. Is there does the terminal say? No, we don't have the terminal here. Adobe. I'm not sure actually. It's now it seems that the server is not running. Maybe we probably need to restart the ODB server. Where how did you start the ODB server? Is it with this here?
Okay, it's also new for us.
The brackets.
Try it out, and I think it's very similar to this pyAnsys package.
Okay.
Yeah, to do everything in Python instead of doing something in Ansys or Abacus. But this is, let's say, more or less a private package, I think, not from an organization. So, but it's totally okay. So pyAnsys, for example, the pyAnsys is a project of Ansys. So pyLife, for example, a project of Bosch. And this one is from some guys who just have to do it by themselves. I don't know if they're related to some company or institute or something like that. Doesn't mean that it is bad or good. It just it's different. Okay, Johannes, do you know how much time do you need to fix it?
Maybe we just try to. Or can I just switch to? No, you don't have. This is German. Okay.
You already told yesterday, but if you can repeat what all the FE inputs are supported.
So right now we using pyAnsys to import Ansys files. With the pyAnsys have a sub package is called pymapdl, and there's a functionality called pymapdl reader. You can read in and you can also plot data with pyAnsys. The pyAnsys plotting functionality is very similar. It's also based on VDK, which we was using today and yesterday to visualize, so there's no differences. For Abacus ODB files, you will see hopefully in 2 minutes, we have written some kind of wrapper around it. This client.
I remember there was some
to overcome the problems with the Python 2.1 problem. And then at least we have an open format. It's called VMap. VMap is not only for FE results, but also for CFD results and other simulation results, either if it's 1D or 3D. But it's, let's say, to be honest, it's not really common in the scientific or also in the industrial environment. It means you can use it. You can also export in some simulation tools
so
your
probably
results
not
directly to
installed
VMap. And we have an interface written for this VMap format. For other FE servers, we do not have explicitly written something. I don't know if there are different export options, so it's no problem to read in any HDF file format, Paquet format, whatever. So every file format which is readable from Python or SciPy or Pandas, we can open and connect that. But we do not have detailed information for Patran, Nastran, for example, or something like that. But we can check it out.
Thank you. And another question that I might get asked at work is how is the safety ensured for the open source software?
Maybe I can ask you, what do you understand with safety?
Because anybody could add, modules or Python. So if there's
Okay, there are, let's say, protection rules. Not everybody can directly commit to any line of code inside pyLife, but not only pyLife, but for all relevant open source projects. There is a process to fulfill, and that looks like that in detail or a technical point of view. It's called, you can fork. That means you can, let's say, some kind of copy this repository. You can make changes by your own and use all changes only by your own. But if you want to push this back to the official pyLife release repository, you have to create a so-called pull request. That means knocking on a door and say, I have something new. I want to integrate it into pyLife. Then the pull request process starts automatically. It's running all the tests through. You have to fulfill some requirements. That means you have to write tests. You have to fulfill the test coverage of the repository and so on. And then there will be a manually checked all new code by at least 2 reviewers. And the reviewers are default Johannes, another colleague. I mean, there are experts. Not everybody can be a reviewer. And if the reviewer says, okay, the new code would be okay, and all automatically requirements are tested and checked and are okay, then we can accept this pull request, and the new functionality will be integrated into pyLife. That means no one can do anything without the acceptance of the reviewers. And that is a common way in the open source or in the software development. Everybody can use the software, everybody can change the software by him own, but only for him, not for all of the users. And that, if that is the question of safety, I think it's more the question of protection and the protection and safety for quality. To ensure, let's say, safety, it's maybe based on tests. We have integrated some different kinds of tests.
I would mention that topic because of I'm trying to explain that to participants quite frequently, but some of you here are newcomers. When you buy a fatigue solver, you are signing end user license agreement, which says that the software company is not guaranteeing safe use of the software. You are the only responsible person for using something which you bought, which you do not know how it works. Yeah. And only the money which you paid and your experience in using it is something which guarantees safe use. So there is no safety, in fact. You believe that the credit of the company would be destroyed if they do something badly, but, well, who finds that first? Yeah. And second, which I noted yesterday in the very start with Faber project, you are also signing usually in the agreement that you will not benchmark the solver with other fatigue solver tools. And if you benchmark it, you shouldn't tell it to anybody. You should not transmit this information. Yeah, so that's about the safety. Yeah. It's only on your.
It's well, that's this really is in German we would say it's opening a very big barrel. Well, what we have, the discussion that we have sometimes inside Bosch is, what happens if there is a bug in pyLife? And so one scenario that people are really scared of is they are doing some component dimensioning with pyLife, some lifetime estimation, and then there is an error happening somewhere, and then the dimensioning is is bad, and then let's say some diesel pump of a new car bursts, car catches fire, whole family is dead. So then there will be an investigation, and then they will ask, okay, how could this happen? That obviously this diesel pump has been badly engineered. And then they said, okay, we did use this pyLife that they at Corporate Research have written, and yeah, there is a bug in there. And then well, it's that's what they are asking us. And then we say, like Jan has said, well, also FEMFAT or some commercial product, they don't guarantee that their results are correct. However, when this happens, or that's at least what people think would happen. What happens is, okay, you've been using like FEMFAT, which is industry standard, so it's not your fault. You're out. It's you. That's what everybody does. We cannot blame you for that. But you use this strange pyLife thing that these guys wearing strange T-shirts have written, and so you should have checked that a little bit more. That's more the thing that we need to deal with. And so yeah, it's there is this. You can also Google this this talk of Robert C. Martin about clean code. And he's saying exactly that. He's talking to a whole lot of audience of software engineers, and he says, okay, we are developing software. How many computers are in the room? I have on my body, I have like 10 computers. There's probably a computer here in this device above the door. There's in the loudspeakers. There's probably computers. There's computers everywhere. When you are a member of our civilization, you are using software all the time, and it's totally imaginable that some poor software developer makes a mistake which kills 10,000 people in one event. It's you don't have to think that much of don't have to have so much fantasy. And so we are actually a little bit in this position, because the scenario that I described is, well, I don't think it's that likely, because we have also experts who then can judge if pyLife made a mistake. So this won't get through blindly, but still it's a scenario that's we have to think of. And when that happens, we want to be able to say, okay, it was a mistake of pyLife. It was our mistake, sure, but we can show you that it was not due to negligence. It was we have unit tests everywhere. This is the way we work, and this is the way people work in software industry. That's the best way that is known to make software reliable, and that's what we are aiming at. So that whenever this kind of investigation comes, we want to be able to say, okay, look, this is what's humanly possible to write reliable software.
Maybe there are two aspects. The one is the legal aspect. And from the legal point of view, we are on the safe side, because we fulfill the state-of-the-art software development requirements. Yeah. And that is also the reason why we have developed pyLife and why we do not use other open source libraries dealing with reliability and lifetime calculation. Because we have to fulfill this internally, and therefore we fulfill it also with the open source library. That is one point. The other point is, as Johannes mentioned, it's a cultural point of view. And for me, it's still the question, can I trust more, let's say, commercial software where everything it's in a black box, let's say, and you don't have either information about the mathematical formulation of the methods, just maybe rough white papers where they explain something but not the real detail? Or can you trust more open source, let's say good open source software, where you can read everything, the pure code, every line, get back to the final, let's say, line and formulation of the problem, where you can find all the tests, maybe also the missing tests, where documented, where every bug is documented, and so on. The history, yeah, you can find everything. For me, it's that more safe, more reliable, and much more transparent. And therefore, let's say, for example, you can have a look, you trust NumPy, you trust SciPy. Because of that reasons, you trust PyTorch, everything, yeah, which is right now standard in modern scientific computing. Because they're doing this way. They are on the legal side, they are safe, and on the culture side, they have much more advantage. Yeah. And therefore, if you ask me if pyLife is on the, how can you trust and it's safe? I think yes. Yeah. And therefore, we are using that internally. Yeah.
I would comment it a bit more even. With Practic, I told you we developed some kind of benchmarking. We were able to prove that Practic for given data gives this solution, and which was for us the final kind of validation. Yeah. And I was for some time wondering, well, that's nice from Practic because I am in that weak position. Yeah, how can I prove to people that it's worth it because of it's for no money? Yeah, and then I ask myself, okay, but all those giants, yeah, are not validating anything. They are not showing such kind of proof to anybody. So why the users are buying that? Yeah. So that's what was the start for that benchmark story, which we are still trying to pursue. And in some moment, we developed something which we called a dummy model, which was a script in APDL for ANSYS, which built an artificial model of a very long stick with many elements on that, and to these nodes were projected data from this benchmark data set. So that means we've built an artificial ANSYS model, which any fatigue solver would be happy to read because of everybody uses ANSYS. Yeah, and we have tested that with 2 fatigue solvers and with Practic. Because of nearly any fatigue solver today implements Dangwan solution for multi-axel fatigue. Yeah. And what was striking for us, first we have found out that every implementation of Dangwan multi-axel solution is different. Yeah, that means you get different results, though the method is seemingly the same. Yeah. But for one of these solvers which we tested, we have found out that there is some strange behavior, that it doesn't provide good results for something like 1/2 of the data set, that the results are non-conservative. So when I was next time in Cambridge in a fatigue conference, I went to the stall because the people were highlighting the product there, yeah, and told them, okay, because we know each other for some time, yeah, we have tried to benchmark your solution, and it gives us very suspicious result, because of in that moment I expected they would be interested, they could cooperate with us. Yeah. And well, the response from the guy was, oh, that sounds interesting, we have to check that. Then he looked around and he said, but nobody is using that multi-axel module. So that was quite funny. Yeah. And what I would like to warn you, yeah, if you are with pyLife, you can find a bug, you can report the bug. You will in some way have to respond to that. When you find a bug in a commercial fatigue solver, you can report it to the company. It's very likely they will repair it in some future version. But what is very interesting, and this is something what I discussed about the culture, this bug is reported to the people and to the companies who are paying maintenance fee. So, though you bought a solver some 10 years ago, which apparently all the time has that bug, this repair will not reach you until you pay all those 10 years the maintenance fee. And maintenance fee is something like 1/5, 1/4 of the purchase price per year. So it's also an interesting point.
Yeah, that's all right. Yeah, that's yeah. We could debate this really long. It's because that's really an interesting story about software responsibility, and we also have been debating this inside the company for really long. And yeah, our stance is what I just said. We are really using to the best of our ability the state of the art methods of software development, and that's why we are demanding this. This is yeah. We yesterday at dinner I said we maybe have already scared away a few potential contributors, because we said we really demand comprehensive unit testing and all this stuff, and we are doing that for a reason. That's why we are doing that. Okay, in the meantime, we have now a working Abacus installation. Thanks to, I forgot your name, Martin. Well, it's a little bit tricky now because I'm a hacker. I use the American keyboard, and now I have here. I'm looking at a Czech keyboard, and it's the German keyboard is set up. So it's I'm a little bit in a blind flight, and because when I use Daniel's computer, it's a German keyboard. I can at least see what I'm typing. Yeah, that's yeah. Well, okay, I think I will manage somehow. Yeah, this is but German doesn't help me because I don't know the German layout by heart. So I have to use the I will use the Czech one, because then I can actually look at the keyboard and see what's. Yeah. Okay. So this here was that's actually the worst case that can happen. That you have to define all the parameters yourself. So you have the path where the Abacus file, Abacus launcher is resides. Then you have the path to the ODB server environment. Probably you could leave that out, and that's we could try that. And then, well, that's what you always need. You need the path to the ODB file that you want to import, and then you can instantiate with those. You can instantiate the client. And then you get like the instance names, and then you get the step names. It has a lot of steps, and maybe I just take one of them. Last step. Okay. Okay. First step equals, okay, that's so that means we have the, I have two mice here, that's confusing. That's the first one is, I need to have shift, okay, so that's the first step, and now we can, I have to check out the docs. Maybe we can make this a little bit bigger. Okay, so then we can also frame IDs. Yeah, that's the first step. So we copy this over here, and so here we say first step. So now we should see here the frame IDs. Okay, so there's two frames. Which one we should choose? Last one. Last one. Okay, frame equals, and then last one we take. So it's -1. No, 1 is this here. 1. Okay, so this is the frame, and then we can yeah, like get the variable names that are available. For example, for this, well, what's the syntax? It's load, and so it's if step and frame. No, it's first step. No, it needs. Well, what? Like this? Okay. First step. Okay, so these are the variables, and then we can fetch these variables. Okay, so we need the instance, the step and the frame, and the variable. So we say client variable of instance. No, it's first we need the variable name itself. So where's the quotes here? No. Here? No. Here? Yes. Like S for stress we can take, and then we say instance, first step, and frame. Right, and then it takes a while, and we have the variables, hopefully. Okay. Node element, that's 400,000 nodes. Is that plausible? Okay. And then what we don't have yet is the node coordinates. Let me just check how we get those. Okay, that's only of the instance. Instance. So what I've, okay, so now we have the node coordinates, and then we can actually join this here. I just named this S. So this is not that ideal how I've done this, because I've now called this twice, so I could have actually put this into a variable right away. Same for the node coordinates, but so yeah, then I will say mesh equals, here's the equal sign, and then I will join the S, and okay, so now we should have the mesh, at least when this has finished. So now this is the mesh, and in the mesh we have now the coordinates and the stress tensor, and then yeah, we can from here we can proceed. We can, for example, do we have pyLife here? pyLife, stress, equistress, and then we say mesh equistress mesos, and then we should end up with the, okay, so there's some, there's a stress tensor. Is this, this is two-dimensional. Okay, that's is that possible? That's okay, it's axisymmetric. So that's okay, that's interesting, because yeah, we need these stress tensors, these stress values here. Yeah, this is also a case that we axisymmetric. Did we have that in the past? Yeah, no, it's yeah. So yeah, again, something that's not implemented because we have not come across it. We have been using axisymmetric modules for yeah, but for this KT1 specimen. That's but that was way before pyLife. Yeah, that's. Okay, so that's yeah. Well, no, it's a thing we need to deal with it somehow. That's, I'm not sure if this is so trivial to add because we have to find another way of calculating the of distinguishing between these two coordinate systems. Okay, but in principle, you can get the data out, and yeah. So we would need to think of a way maybe to also to augment the data. So there's some options. So yeah. Okay, if you have a different model available, then of course we can. It's here, yeah. Mhm. Okay, let's see if that works. Okay, that's probably. There's something wrong with the path. Slash here simulants. Yeah, that's the problem that the backslashes are interpreted differently. So we have to change them to forward slashes. Where's the forward slash? Here. Oops. Yeah, that's quite a common problem when you're dealing with Windows and the Unix world where Python is coming from, because in the Unix world the backslash means masking special characters, and so this backslash f is interpreted as some special character, and that's why it did not work. So okay, yeah, it worked. So now we can actually step through it step by step. So yeah, so I have the. It's good that I have not taken that I have put the step names, instance names into variables. Is it still the first step that's decisive? It takes long for the frame IDs. I don't know why. It's okay. So let's just see what happens. So this is still the old one. So now it's still hanging here. It takes a while for the frame IDs. Maybe we check the. It's a big one. It's a bigger one. But okay. So let's see what happens. Yeah, that's a little bit of the problem. This client server architecture is not that it's not that performant. I'm actually wondering why where the bottleneck is. It's yeah, maybe we should check with a model that has many frames. We did not have those that much. And okay, now the frames are here. Now we check the variable names. Yeah, well, it's slow, but it seems to work. Yeah. I'm a little bit curious where the bottleneck lies. If it's in the server part, or if it's the inter-process communication, or if it's in the client part. Because, well, just getting the variable names, this shouldn't be too hard. This is just a couple of strings. Yeah, but then we cannot do anything about it. If it's on the ODB side, then it's, well, okay. Couple of variables, and now we get the variables out, so the S is also there. Yeah, it would be interesting to benchmark this with the other solution that came up in the chat. Okay, so while this is running, are there other questions? It's 12 o'clock, time for lunch.
So in case I encounter the same problem as Martin, I have to define those paths, right? But I haven't seen any instruction in the.
Yeah, well, it's in the where do we have the docs? So it's here. What you need is it's these here. You need the abacus bin is the path where the abacus binary resides, and the env path is the path where to the ODB server environment. Well, ideally, it guesses this. If you we could if you have if the environment is called ODB server, it should find it automatically. Also, the path is guessed, but this a little bit depends on your installation if it succeeds in guessing it. So you need to supply this one. So that's the instructions that we have, and yeah. So this is ideally it looks like this. So then these two are guessed, and yeah.
Okay. Thank you.
Here we go. And we have our Mises stresses here. So that works. And with that, we could go in anything that we've shown yesterday with the 3D things and stuff.
Just a comment. I checked how it is with Python and Nastran, and also there are some interpreters, some libraries. So Python is mighty tool.
Yeah, that's well, Nastran is something that we cannot do on our own because we don't have Nastran available, and so yeah. But we would welcoming any suggestions. All right.
So are there any other comments to say transfer of data to pyLife or whatever else which we discussed until now? Concerning the safety of using pyLife in other software, there is one more comment from Benoit. Don't forget the problem of the software company that changes its internal engine without explaining it to their client. You based your practices on a version of the software and one day it doesn't work anymore, or worse, you don't notice something changed.
Yeah, that's really an interesting point. And we can also tell you how we are doing this, at least internally with pyLife. So we have these, yesterday you have seen these unit tests. So we have a unit test. We can also show it how it's running live in the afternoon. And what we are doing is we have a separate repository. And there are the test suites of the older pyLife versions in there. And then we ask our internal customers, the users, when they have set up something with pyLife, they should write a test suite, something that that tells them, okay, it's still working as it worked when we have written it, and then they can file a pull request to our test repo, and then we integrate this test suite these tests into our test suite. And whenever we do a new pyLife release, we run it against the old tests that people have brought us. And so then, well, ideally it runs through. Yeah. If it doesn't, then we look into it. Yeah, maybe we messed something up, then we will fix it before the release, or maybe it's really we improved something. Well, often it's just a rounding issue. It's not. It's a rounding issue. Floating point arithmetics. It's not an error. It's just a rounding issue that some data frames are not 100% equal because the precision is too low. And sometimes it happens that we are really changing the behavior because we think the new behavior is better, or maybe the old behavior was plain wrong. And if that breaks tests from our users, we discuss that. We say, okay, look, this test is no longer, we looked into it, we think the new behavior is better. And then what we do, we disable this. When we agree that the new behavior is better, then we modify this test, and the old test we let in the code base and just mark it as to be skipped with the comment discussed here. Here's the discussion thread why we decided to skip it, and then it's documented why we changed behavior. That's yeah, the way we are handling, and this is only possible when you have the code in your hands. Yeah, it's, because then you can run it against your old tests.
Well, that's kind of solution. I would mention what I noted before about that potentially wrong dunk one routine in one fatigue solver. Imagine that contrary to the expectation of the guy who was trying to sell that software, some users are really using that multi-Excel module, and for quite some time they use it. They had to validate it on their company products. They could find out it doesn't work perfectly, but they found a mean how to correct it. Yeah, and now somebody announces, okay, that was a bug there. We will improve it, and now all those safety measures which you had to apply originally were fitted to your company experience, and now somebody tells you, okay, we can do it correct. You can do it correct, but that means another round of validation, and again in your company. So that's quite a big. It's a really serious problem. How to deal with that with your users and so on. And that's also something which a bit startles me, because of if a company sells a product, it knows where it goes. With pyLife, if you find a bug, how to reach your customers, how to let them know, well, we have a bug there, you should check it, how it works now.
Well, that's what we use the issue tracker for. That's it's now also when we actually started to open source it, we had to learn that a little bit. That now if we have a bug that we cannot fix immediately for some reason, then we will put it on the issue tracker. And then on the issue tracker, there's there's also labels. There's labels for documentation, for code readability, for all this. And there's the red label is bug. So if we know about a bug, which we will fix maybe at a later point, we will put it on the issue tracker so that everyone can see the known bugs. And then with every release, we have release notes. They're in the changelog. That's not that long because we only change a couple of things. In some releases, it was just fixing dependency problems, and but we try to be as transparent as possible. And that's also, we try to be transparent with the things that we are discussing. We are sometimes we are discussing internally with Daniel and Benjamin, the third colleague of who's now into pyLife. We are discussing things in the office at the coffee machine, and then we said, okay, we should actually write this discussion on the discussion panel in order to make it transparent. There's also this this funny. Sometimes we are a little bit reluctant to not talk about internal stuff. For example, there was one discussion where somebody proposed something, and then Benjamin said, "Yeah, that's a good idea because Christina will also need it." And they said, "Okay, should we mention that Christina will need it for her project in public?" That's a little bit. Then yeah, where's the limit there? But yeah, we try to be as transparent as possible. And so if you follow our if you watch the pyLife repo, then you should be informed about things that are going on. I'm not sure if you can actually subscribe to the issue tracker.
That would be a very interesting solution.
I'm not sure if GitHub can do that, but if that you get any issue that's or any issue that's labeled in a way, that would be a GitHub feature. Maybe there is something like that. And to say, okay, I only want to the issues that are labeled as bug. Yeah, that's we can look into that. If there's this feature, we would put that into the README file. If you are interested in bugs, everything that we know that we can't fix in like a day. And then it's also what we are usually doing when we have a bug that's really serious that we will fix in a day. Then we mostly immediately do a release, and then it's there's a release note bug has been fixed, and so sometimes it's that's not possible for whatever reason that we release immediately. Then the bug is fixed, so the issue is closed, but it's not in the current release. That's also might be some issue. Yeah. But yeah, with serious bugs, we would probably do a release immediately.
Yeah, so some kind of ability to get the information from the issue tracker to automatically to my email box, that would be fantastic. By the way, that was something of what Practic allowed. Yeah. Anyway, I would propose now to make a break for lunch. We will meet again 14:15. That means 64 minutes from now. And you could see yesterday that definitely the prices of the lunch in blocks were much better than for the dinner. So do not hesitate to join me again if you want to eat something.
Okay, should we proceed? Or I don't know how many are joining online, or should we wait? Okay, then maybe we can start. Okay, before we go back to pyLife and also discuss the next steps, what's in the pipeline, what have we planned, but maybe also what have you planned, or what's are your requests on pyLife? We was asked several times today and yesterday also which kind of collaboration would be possible, especially for universities and the scientific community with Bosch. And of course, we have, I could say, a lot of possibilities and options. Well, let's say we have some of it. Yeah. So it's maybe we have to distinguish between students. We have for students, we have a lot of internship pre-master programs. We have a lot of master students who are writing the master thesis. Maybe that's not so important. That's just the development opportunities. We have a lot of, let's say here, bachelor master thesis. We are doing together with a lot of different universities, not only from Germany, but from, let's say, all European countries at least. And also bachelor thesis. We have sometimes, if you have finished your bachelor and want to start the master, we have a so-called pre-master program, which leads you through the whole master time, and you are changing always between university, and in the semester breaks, you are working inside different Bosch locations, research and development locations, to see a wide range of research and development inside Bosch. And of course, we have here this PhD program. I think in Renning we have around 150 PhD students, maybe more than you have on your institute right now. And and they are working in a lot of fields. So I have also one PhD student at the moment. He's dealing with nonlinear dynamics and data-driven approaches of it, for example. We have a lot of PhD students in the past, but also right now in micromechanics, material science, and the influence, for example, of hydrogen or so. Therefore, we are working, we try to work really closely together. The students are paid with universities, the PhD students are paid by Bosch, at least they are employees by Bosch, but they have to make the PhD at a university. That means depends always on the collaboration between the professor and us, where he is sitting. He's sitting at home, make it as a home office work. No, it's not the best idea I would suggest for a PhD. But for example, for the student I try to mentor, he is the half time at the university and the half time at Bosch. So that's not fixed. That's still upon the collaboration between the university or the institute and the professor and the Bosch department. Yeah, we have also others. If you have finished your PhD program, we have a lot of opportunities to join, especially for PhDs directly after PhD, the Bosch Research Group. That was the way as maybe Johannes did, and I just spent 2 more years in another company, but then I decided it would be the right decision to go to Bosch, and it was. Yeah. And we have also, it's maybe a little bit tricky, something like working students in the Czech Republic. That's common in the Stuttgart area. So, all right, that are the most interesting opportunities. We have one additional one only for the scientific community, and that's only possible at Bosch CR, the corporate research. That is called, I don't know, it's an industrial sabbatical. You can work for, I think, 1 year or half up 6 months up to 1 year. You will pay by Bosch in this time, and after that you have to go now. You should go back to your university and proceed, let's say, more or less a collaboration, which hopefully will be established in that time, or you can also work, of course, in other fields. But that is something to accelerate the exchange between scientific community and Bosch research, and also to give researchers the opportunity to see what's going on in the real world. Okay, I don't know if just one sec. Yeah, it's just a link. What we are doing, I think all other stuff is not so important for you right now. Yeah, maybe one last topic, just shortly addressed. So you have different career paths. So you do not have to be management at Bosch. If you are specialized in some research fields, you can also become something, it's called a senior expert, and go to this path. After that, maybe you can become something like a chief expert. It's better paid than a professor and makes much more fun, I would say. Because you don't have to teach students, you just can go to conferences, write papers, have a lot of students around you, can also mentoring PhD thesis and so on. So that would be also an option. All right, so far to the options you have if you're interested in. Everything else. If you have a topic which could be interesting and you think makes sense to collaborate with a master thesis, for example, a bachelor thesis, just contact us and then we can discuss this topic, how we will proceed on a dedicated case. Questions? Or is there something else who wants to hire also people and want to make some marketing on that? No. Okay, then we go back to pyLife, and of course, come on. So now we are here in the 5th point. So it's a question, what's next? What we have planned, but also what could you imagine what should be in pyLife in the next release or maybe in the next years? And what do you think in which direction we should develop pyLife further? Maybe we can start with, let's say from our side, what we have planned. And I think, Johannes, it's much more easier. You will talk about that because you are much more involved in this topic.
Yeah, right. We actually have a slide about that. A small slide right in the end. This one. All right, so that's just a couple of things that we have in our issue tracker and that we are thinking about. So short term, what we want to do, we have this FKM nonlinear branch that's or this in the development branch. We want to actually release this if everything works well in like February, and until then we need to stabilize the API. We also need to get this discussion done about the residuals. And so maybe it will take a little bit longer, and we will think about a couple of optimizations. Then in midterm, we are, yes?
Concerning FKM nonlinear, sometimes in February they expect to release new version. This will be integrated?
So at the moment, the current version is 2.1.0, and then 2.2.0 will have the FKM linear, nonlinear integrated, this functionality. So it's, we are still... Okay. Oh, well, I'm not too sure what's the exact state of that. So they...
So 2 colleagues of our department are involved also in the development of the FKM nonlinear. And I think they had deep exchange with Benjamin, especially. So in the project where we internally need the FKM nonlinear or where we want to apply. And therefore, I think it should be the new standard. It should be, but I cannot guarantee it right now. Because they know all the new features, and I do also cannot guarantee if we have every topic of FKM nonlinear is implemented, but the most relevant, definitely yes.
According to what I've seen in the code that they've written, they have already some draft of the new version which they have used.
I would mention that we had a FKM nonlinear workshop here just a month and a half ago, and the lecturer Clemens Rotter from HU München told us that during preparation he found quite a lot of bugs in the original first version of FKM nonlinear. So he discussed that with the originators, and it should be fixed in the second version.
Okay.
So that's for your information. And second, I wanted to ask, this is about FKM nonlinear. What about linear version?
Yeah, this linear. We need a couple of a subset of FKM linear for another project. And as I said, when we program something for a project, then we think which part of that would make sense to integrate into pyLife, and that's for that project a subset of the FKM linear. And this is a project that will officially start at the beginning of the year. We have already started working on it in order to see how it could evolve, and so this will probably go into the more midterm. So in the release after that will come later in the year, after February. But we are not sure which subset actually will go into it. But we hope that we can do it in a way that it's like a little bit obvious how to add further subsets.
Yeah, but maybe one more comment on the FKM linear. So everyone is waiting for the pyLife FKM linear, because most of the internal users want to have, let's say, fast and rough estimation of the fatigue calculation. We have, I think, an internal branch on another project which has implemented 90% of the linear, but this code does not fulfill all the requirements we have based on code quality. And therefore we have to refactor it, and we have to bring this to a stage that we can say we can finally merge it into pyLife. So we know that there's also an internal need, and that is, let's say, right now our main driver. And right now we see that it's not so much effort to bring FKM nonlinear into pyLife, but we know that it's not, let's say, normally you would say first of all we need linear and then nonlinear. Yeah, we know it, but we're working on that.
Okay, then this is like a smaller issue, the Cytonizing the rainflow counters. I've talked about Cyton during dinner, so for those who were not at dinner, Cyton is actually a programming language which is in Python syntax, but it's transpiled to C, and then from C compiled to machine code. And this is quite a common way to accelerate Python code, and we want to do that for all these rainflow classes, and we expect that we get a performance boost of like, let's say 50, 60, 70% or something like that. And that's what we want to try out. And then this is the more long-term stuff, which is like these like more nebulous plans for pyLife 3. That's integrate Dusk in the parallelization. As I told you yesterday, we have this broadcasting facility, which we might show later on, that actually makes cross-product operations, so it makes huge data frames. And so with Dusk, you can actually handle those. And we are thinking of finding a way to make the broadcaster use that. Then this is introduce of type hints. This is more like a software development thing. It will not introduce that many new features, or it will not introduce many new features at all. This is just for convenience for better code quality. Type hints are, well, Python is usually a dynamically typed language, so you don't have to tell this variable is an integer, or this is a string, or this is a float or something. You don't need to tell Python this. Python will figure out itself. And this is actually quite funny in the history of programming. And when programming started back in 1940 something, in the 1950s, then types were actually something you needed to deal with, because the computer needed to know how to deal with the bits. Yeah, what the bits mean, and that's where the types come from. And it was always a hassle with dealing with all the types. And then when the computing power increased, they said, okay, we can actually use a couple of those bits to tell the computer which type that is, and then the computer can knows what to do with it. And that's dynamically typed languages like Python. And then, well, two things happened. There were the dynamically typed languages. They were slow, and then at the same time there were still the statically typed languages. And then the type theorists came, and they thought they were computer science. They actually found out that types are really useful. You can actually make use of types to write better code, and you can also make use of types so that the computer can actually help you write code, because when the computer knows what type a variable is, it knows what you can do with it, what methods the class has. And so then the funny thing is, now dynamically typed languages, they have something like type hints, so that you can optionally write the types that are supposed to be there. It's then not mandatory, but then the programming language knows what type to expect, and then VS Code can help you, and with VS Code also can warn you are not putting in the type that you are supposed to put in, and that helps you to write better code. And so that's at the strategic places in pyLife. So that's the places that are called often. We want to introduce type hints to just help the users of pyLife to write better code. That's also something for more long term. All right, and then of course here your ideas. So it's maybe I also told it in some coffee break yesterday. We are not now no longer really developing pyLife just to develop pyLife. So the initial pyLife project is finished, so we are just developing pyLife in the scope of other projects. That's where the FKM nonlinears and all this stuff is coming from. This is just other projects that say, okay, we want to implement that and we will put it into pyLife. So this is no dedicated pyLife project. And so this is also what we can do together with you. So if you have a project where you that you could integrate into pyLife, or where you could develop something that could go into pyLife, we can supervise that, and for that we always have some capacity. So it's not unlimited, but yeah. So if it's if we feel it's important, then we will support that, and yeah, we can talk about that.
And it's not only us, Johannes and me. There are some, for example, we mentioned sometimes Benjamin, who is also really involving and contributing to pyLife right now. And there are more and more Boschler, colleagues from Bosch, who are not only working with pyLife, but want to start to contribute. So that means, if not only we have to do anything and everything, then the development getting easier and also faster. Yeah, as you can see, we are focusing right now on the FKM topics, but of course there are a lot of different other topics, which can be addressed to pyLife, and it makes sense to discuss if they should be integrated into pyLife, or should we have a side package which is dealing with pyLife, so for example, and use a lot of algorithm of pyLife, but is more or less separated. That could be also an option. It always depends. We cannot say yes or no for one use case. So it depends on the use case.
May I ask that stress invariant solution for multi-axis fatigue will be integrated into pyLife?
Yeah, that is, we are planning to investigate that in the next year more and more on different test benches and different use cases, and also with our existing database. And if we see that this functionality is working quite well, then we will integrate that, I think, also in pyLife, yes. There's another toolbox which is dealing with vibration fatigue. And if we have this, let's say, if we have the decision that we want to use this as a standard for Bosch, for multi-axial fatigue, then we will discuss if we integrate that in this, let's say, vibration toolbox or in the pyLife toolbox. But I could imagine that we do it also in the pyLife toolbox. So that would be an additional equivalent stress class.
Mm-hmm. Okay.
But so in Bosch, or sorry, in Germany, most you have to double check everything. Yeah, we are convinced that this approach is a really good one. Yeah, but we have to double check it once again.
I wanted to mention that, the reason why we invited Johannes and Daniel here is because we would like to join the project in some way, in cooperating and implementing either into pyLife or on top of pyLife some multi-axial fatigue algorithms, because of this is what we basically do here.
Mm-hmm.
That's what Practic was strong in. And we have not only Practic code, which is in C++, but also some MATLAB toolboxes defined and so on. And Peter, in next month, should start to rewrite the MATLAB content into Python for his first tries. To analyze, to learn multi-axial fatigue, in fact, by writing that. So we expect multi-axial fatigue should be involved, at least in that way, either in pyLife or on top of it, sometimes relatively soon. Yeah. Second, I have a PhD student who is not here, but he's dealing with fatigue of welded structures, specifically thin walled welded structures. And there I feel also what was written here in the chat, that the complexity of such analysis as regards any manual work with the mesh is terrible. Yeah. So also there we would be quite interested to follow some kind of mesh processing routines to implement them into pyLife, so that this reading these features would be simpler.
Yeah, so there's it's a variety of projects, and such is also the variety of ways of collaboration. So we can, for smaller contributions, we can also, that might be also interesting, we can organize a hackathon. That we would plan a little bit ahead, so we could do that, for example, in Renningen, like a couple of days. We would plan some things that we want to implement beforehand, and then we do it together. We can also do that on one of these Python conferences like EuroSciPy. They often have a hackathon day after the conference itself. We can do it at such an event, and then also see if other people from the conference want to join. And we can also, for bigger contributions, we can also find a way of collaborating in a master thesis or a PhD or
starting. So what we see, maybe just try to answer your two questions. The first one is the multi-axiality. I think that fits perfect in topics we have already integrated in pyLife and what pyLife stands for. So we should discuss. And from my point of view, there's not or there's mostly not only one valid solution. So if you have different options, yeah, and methods, we are really open to implement that. Yeah. That means the one we have shown in this morning, it's not the only valid one. Yeah, there are existing different one, and all of them have advantages and disadvantages. So that is the first topic. So we are really open, and we can maybe later discuss it separately how we want to proceed with that. The second topic is this mesh functionality, yeah, and mostly mesh functionality comes or very often with welding and welding problems. And here we have to think. So all mesh functionality we have implemented already. All right, in pyLife is just implemented because we needed it, yeah? And not only because we believe in FEM or something like that. So we believe in reliability, yeah? and lifetime calculations, but that was just to get local damage on meshes. So we are not focusing on make the access to meshes easier or to find good mesh and something like that. I think that is really, really interesting for us. But that is not the main focus on pyLife. And maybe for that topic, it makes sense to have a separate package, but with defined interfaces, for example. Yeah. And maybe also one side note from regarding to welds and joints. So for welds, we have let's say more or less, yeah, internal Bosch approach to deal with welds. And I don't know if that fits with a general external worldwide approach. Yeah. So we are not really dealing with this problem of how you create a mesh for that. So.
No. Okay. Right. Another question.
How likely it is that pyLife will be charged for in the future?
Won't happen. No, it's won't happen because pyLife as of now is property of the of Robert Bosch GmbH and all the other authors that contributed. So TU Darmstadt has parts in it. It's Apache licensed. So we cannot technically relicense it. Because then that would be quite a difficult process. What could happen theoretically is that there will be charged for additions to pyLife that can be done by anyone. So anyone is free to do additions to their own pyLife version and charge for that. That the license does allow that. That we at Bosch will do it. I cannot imagine that will ever happen because that's not our business. It's not what we are. We are not dealing with. We are not in the software development. And we would need to build up distribution, marketing structures, and I simply don't see that happen. So as I said, what could happen is that some other player comes in and outruns our effort, makes a even better pyLife, and then charges for these additions. That's a theoretical possibility. Well, then we cannot stop them. Yeah.
Just if I can comment back to what Daniel said about multi-axial fatigue modules. I would like to comment that in FKM nonlinear and FKM linear, there are currently no specific versions for multi-axial fatigue dealing. Yeah. As I was informed from Ima Dresden, from Roland Rennert, for FKM linear, they plan to release a new version of FKM linear sometimes in 2026 with multi-axial fatigue solution involved. but the typical delay there is something like 2 years. So he told me, yeah, I'm ready to present FKM guideline again here in Prague once we release the new version, sometimes in 2028. Yeah. Which is quite far goal, yeah. But anyway, concerning the multi-axial fatigue model, yeah, there are plenties of different solutions dealing with that. In practice, we were implementing something like 20, 30 different methods, yeah. And for our, say, research practice, that's something what we would like to continue. That means to offer a plenitude of methods which can be used. And also what is interesting for me is to provide the users information, what are the pros and cons of each of these methods. That means also to have a way how to digest automatically those benchmark sets and to make the tests by themselves and so on. Also, it means what I would be very interested in is how to establish a material model. That means here we are using mostly some abstract models of Weller curve, for example, but basically it's driven or based on experimental data which have some scatter. These experimental data should be, in fact, injected into some specific format of say, CSV or any ASCII file, where it could be stored, and this information should be uploaded into, for example, pyLife or whatever else. There should be some format for running this or for writing those experimental result data. Yeah. So that would be also quite of interest to me how to proceed here, because of, as I told to the audience, we think that what the users deserve now, not only from pyLife but from any fatigue solver producer, is to get some scope of information related to using the module. Yeah. And this is what I miss everywhere. I have to check pyLife. Yeah. But that would be also a part which where we would be very happy to help, because of we have some experience with that. We have some experience with benchmarking, and also the Faber project, which I mentioned the first day in the introduction. It's all about that. Yeah, we should ensure that people use the fatigue solvers responsibly, that they know what they are doing, or at least they rely on some our benchmarking as some kind of default method. And if they are interested to know more, they can find the information. That's currently not like that, I would guess.
Okay. All right. Further questions or? Okay.
If I can have a question, because of that, something what interests us, yeah. You told us that after every or preparing a new release, all those tests are done to be sure that no serious change was introduced during new updates.
Yes.
Can you show us a bit more about how to structure these tests, how to build them, how to organize it?
Yeah. Okay. I can show that. How do we? Yeah. Maybe I will show that in even in my computer. Just let me prepare that real quick. Oh, no, I need to re-log in. Oh, gee. What's the password here? Yeah, okay. Just
distinguish between different kinds of tests. So let's say on the basic level, we have so-called unit tests. Unit tests test, let's say, the functions. Yeah, that, for example, if you have a function implemented, if the function is doing the calculation correctly. That could be more or less easy if you have an easy function to calculate, for example, the equivalent Mises stresses. You can do it for different nodes, or if you have a stress tensor by hand, because you know exactly the equation. You can do it also for mean stress. So that means the test is really easy to write and also to run. Yeah. So that now it's come a little bit more tricky. If you have, for example, the rainflow calculation, okay, if you have a sine signal, it's very easy to check if your rainflow signal is calculated in the direct way. Yeah, you can do it also. You can also deal with residuums. You can create synthetic signals that you can check and test it. But you can also test that against, for example, commercial software or other routines which are implemented. So that is a unit test. And but that is not only running, let's say, a whole tool chain or simulation chain for the end users. Yeah? But these unit tests are done every time you have a commit. So always if you change something, the unit tests run firstly on your local machine. And if that is working and nothing is broken, then it runs also automatically on this GitHub. And then you have so-called integration tests, for example. Integration tests are dealing to, for example, that you check if your Jupyter notebooks, you have different Jupyter notebooks with a simulation chain. You're doing firstly, as we showed, time series evaluation and then the damage calculation, for example. And these tests are checking if everything is working correctly. You do not have to do it manually. There are also so-called GitHub actions for that. That is some of these actions is, let's say, they start automatically these test routines. And there are also functionality tests. There are different kind of tests I just mentioned. And the smallest tests are the unit tests. You can run it very often because it's fast. And you have different tests which takes much more time. And some tests you are just only running before the release because it takes maybe 1 day or something like that. And we, or Johannes will show, I think, the different kinds of tests and how that works, how you can run tests. It's also integrated in the Visual Studio's code suite, for example, to run automatically the test. Also to see the test coverage. That means how many lines of code are tested. And for example, if you have some if causes and so on, can test if every option is tested. There are a lot of possibilities to write these tests, but on one time you have to start with that. And then maybe you can be also more professional in writing such a kind of test.
Okay, so maybe I will just, can we see it now? Maybe like this. Does this work? Okay. No. Oh, it's this. It's the scaling. Then I will do it like this. Okay, here we go. Oh, it's somewhat strange, but okay, let's deal with it. There's something strange here. Come on. Yeah, probably I will need to I think it's due to the scaling. Na, come on. Ooh. Okay, maybe now. Okay, that's looks good. That's the default background of the Manjaro distribution. Don't know what it is. No, come on, stay there. Okay, so now here I'm in the default pyLife directory, and I will just show you what happens if I run the whole test suite. Or it's actually only the unit tests. We use the facility pytest. This is well, the most popular test runner of for Python. So it's now going through the code base. It has collected this 1100 tests. That's the current master branch, and now it's testing all the tests one after another. Yes, this is what I also told to some people in the coffee break. We have one Wöhler analyzer that we have not shown yesterday, which uses Bayesian optimization. It is way slower, but it actually converges faster. You can use it with a smaller amount of data points. That some master's student has suggested that, so that slows down the test suite a lot. And so it will. So every of these dots, of these green dots, is a test that has passed, and we might just take a look at how a test of like this looks like. So this is. Do I have the focus here? Yes. Okay. Now we are through this. So we have here, for example, which is the Wöhler curve. So remember, this is what we've done yesterday. So this is like this is a test function. So this file starts with test underscore. It's a Python file, and it has functions that also start with test underscore. And these functions are tests. They are found by the pytest runner, and so this function here initiates a Wöhler curve, and then so this Wöhler curve here is valid for a failure probability of 0.5, and what we are doing here, we transform this Wöhler curve to a failure probability of 0.9, export it back to pandas, and then we know that we have calculated that by hand, or we have selected the values in a way that we can easily calculate this. So then the SD, which was here 300 times square root of 1, must increase to 600, and also the ND must change accordingly, and the failure probability, of course, must be 0.9. And now let me just check if the test suite, the test suite here, now the test suite has been run successfully. So we can see here that the result, there's some warnings, and then we also get the coverage. So every file we have here, we can see which how many statements there are in a file. Like here, this broadcaster is quite big. It has 137 statements, and 2 of them are not covered by the tests. So yeah, what I usually do is we check if what statements they are. Usually they are just an error handling of an error that you cannot trigger that well in a test. You know that might occur, that there's like a division by zero issue or something like that, and it would be a little bit too difficult to actually do a test that triggers that, but you still handle the error that might occur. And yeah, so this is how a test suite works. Yeah. Yeah, maybe I will just run this one here. So these are the transformations of the Wöhler curve. So we transform the Wöhler curve from a 0.5 failure probability first to 90, and then here we transform it back. We take the 90% Wöhler curve that we just transformed, and we transform it back to 0.5 failure probability.
Maybe one comment. So maybe try to understand. Every one of you is really new in write tests. So that here just means we have this pandas class, and pandas come also with a test class, which is set up based on PyTest, I think. Yeah. And here just compare two different pandas series. So we have talked about data frames and series. Here we have a series. Here that is the one series, and that is the other one which is calculated. And we just compare the columns, the index, the values, or pandas is doing that. Yeah. And if there's something missing or something different, then you get a failure and their test is failing because of that, and you can fix that then.
Oh, I have some urgent need here. I need power.
And you can do that also. So NumPy has also a test functionality that you can compare different arrays, scalars, or whatever you want. You can also, for example, just compare if the values are the same at pandas data frames, the tolerance, the relative tolerance, the absolute tolerance, and so on. Yeah.
Okay, so what I'm just to show you how the usual way of working is when I do that. So I just ran this test. I have a shortcut for that in my IDE. Also, Visual Studio Code has that. They have a button next to the test, so you can just run this one test. And now, yeah, we can. So these what Daniel has mentioned. These are called assertions. I can also put in another assertion here. Assert 1 equals 2. So that's a false assertion. When I run this test now again, it will fail. So it says here 1 equals 2. This assertion has failed. And now when I can also break the production code when I go to the actual Wöhler curve. So here's the code that actually is tested. Well, let's change something. So I will drop this 0 here, and then when I run the test again, it's false because the series are different. So that's the way unit testing works. And so for the more like integration tests, we have done this in these Jupyter notebooks. So this is what you to answer the question, how would you structure the tests? So basically, you would do these kinds of PyTest functions. So you would set up a repository with a set of test functions. Test functions are functions that are in a file called test underscore something, and they need to start with test underscore something. And then there must be any kinds of assertions. It can be just the plain assertion, like I showed this assert 1 equals 2. You can check some condition, or you can also use the pandas facilities from pandas testing. They have a couple of facilities. Also, as Daniel said, with floating point precision handling and all this stuff. NumPy has it, and there's a couple of others. And so there's a lot more to unit testing. There's sometimes you need to establish some context. So it's here it's just you set up the series, then you do something with it, and you check if the result is as expected. Sometimes you need some more context. You need to, I don't know, set up a connection to a database or something. And there's lots of techniques in unit testing how to do that. That's really a whole discipline in software development. And this is unit testing. What then happens is that yes.
So on Visual Studio Code.
Yeah, okay, show it.
Because most of you, I don't think, using Emacs.
Yeah, that's maybe a good idea. So just
interested in. Maybe first of all, we have a look on.
Oh, let me just grab this one.
So if you go, or if you figure out of if you should use a repository or a Python package, what I always do, it's in the first step. I have a look, of course, at the code, maybe at the stars, but much more important is we have here our source where our pyLife is implemented, and here we have our source code. Yeah, if I go here, for example, to mesh, and then we have in the end here the gradient functionality and so on. But we do not have our source code here. We have also here one folder with tests, and it's the same directory built up also on this test. And we have for every function, we have several tests. So for example, if I go also here to mesh, and then I have here something which is written as test _ gradient, and hopefully we find something here. Yeah. Now, of course, here we are testing the gradient functionality. Yeah. And for that, we have for every function we have implemented, we have several tests. And this test, you can see, it could be really, really easy, or it's also sometimes a little bit work, to define such kind of tests. So for example, here you can see we are defining a really small set of nodes and elements to test this functionality. That is the one topic I want to show, but you can see it also on just pyLife directly in Visual Studio Code. I just will open pyLife here. Come on. Okay, so you can see here also the structure of pyLife. I have here my source code. Oh, come on. Takes a little bit. So here I have my source code with mesh and so on, with the gradient functionality. You can see here. And I have also my test functionality with the gradient. You can see here. Yeah, come on. And now is the question how to run the test. You can do it manually. Here's also the test functionality. I don't know how long it takes. So to run the test.
The whole test with like a couple of minutes.
Yeah, let's try it out. So here's always asking me, configure your Python test. I have this PyTest installed. So I will use PyTest framework. Do I need some config file? Test.
Oh, it's actually in test.
This one here, and now it should work. Come on. So it's activating extensions. Oh, it's still working. Come on. let's run all the tests. Oh, that's the life hack. And come, let's do it once again. We do the PyTest framework, and we do maybe here the root directory. Oh no, it's working. It's coming. So tests. Hopefully, let's run once again. Oh, it's working here. So now here you can see all the tests are running, and take some while if it's initialized and started. But then you can run your tests, and if you see something is failing, you get a lot of information how to fix your tests. So that is also possible to do it directly in Visual Studio Code. Yeah, okay, you can see here, everything will be green. Oh, come on. Maybe we can enlarge this a little bit. So here the core is right now tested, and now we go through the whole test suite, try to run the tests. And if I will change now something in some functionality, I can rerun it, check if the tests are still working. And otherwise I have not to change the test, but the function. Yeah.
Have you got somewhere some test configuration? Like, because I checked PyProject Tomu, or I was trying to see some conftest.py to like just see the configuration. I was wondering, have you got some file that I could see?
Look into setup.config. Setup. Yeah, we can look together. Oh, there's tests failing. Why are they failing?
Yeah, because I have a different branch. So
okay, so you're on.
It's not the development branch. I have to.
You have broken something.
Yeah, of course, that happens in development. So let's have a look here of the setup config file. So come on. So
that's a little bit further down. There's somewhere it says PyTest. Yeah, from
here,
there on. Yeah.
Here.
Okay, so that's basically what it says here. Maybe I will just explain it. So there's we have some markers. One is called slow acceptance. I actually don't know if we are still using it. That's for tests that take longer. They are not run by default, but you can actually ask it to run them. I think we don't have those anymore. Then the demos, that's more like the integration tests. That's the thing that Daniel has explained in the beginning. The unit tests, they are just testing a small, tiny thing that you are about to program, whereas integration tests, they test like a more complex calculation chain, and they might also test if your software works together with software of your colleagues or with some third-party software. That's integration tests, and as pyLife is a package, we don't have real integration tests for those, so we have those for applications that we base on pyLife. However, what we have these Jupyter notebooks, these demo notebooks, and we have a couple of important ones of them. We actually also set up tests for them, and they run the Jupyter notebooks. And then in the end, we have some criteria. Maybe we can just look at those. That's here in tests. Where are the tests? Oh, that's source tests. There's the demos here, and we have actually one file, and it tests here. For example, the hotspot beam. So yeah, we have to. That's a little bit hacky. For example, the PyVista plotter. When you remember this hotspot detection notebook from yesterday, it plots these hotspots, and so this would mean that when we run this test, then PyVista will try to plot it, and then when we run it somewhere on the GitHub Actions, then it says, okay, I need a graphic card because I would need to do 3D rendering, and then the GitHub Action runner says, well, I don't have a graphic card. I'm just a server, and so we patch this. This plotter that it doesn't actually plot, because that's not what we want to test. But what we want to test is here we inject a new cell here in the Jupyter notebook, and we say, okay, so the first hotspot consists of 1296 nodes. That's something we checked, and that's something we know is correct. So it's that's the tests we are doing for these 3 hotspots that we have. And as long as this is still the case, we are confident that the function, that all the calculation is still correct. And what we usually do when we have a more complex simulation chain, so when we are developing a simulation method more in this explorative way, then we usually have it validated somehow. So it's a complex simulation chain. We put in data here, some other data here, and some other data here. Finally, we get a result, and then we validate the result from a scientific point of view, maybe with experimental data. Then with our expertise, we say, okay, from what we can say from a scientific point of view, this calculation, this simulation makes sense, it's correct, it's plausible, we consider it validated. And then we write such a test function which actually does the whole calculation chain. And this we then can use with newer versions of pyLife, newer versions of I don't know what, to see if everything is still working. Yeah. So that's this PyTest. And well, maybe we can show, yeah, maybe we can also show, or are there questions so far?
There is one question from online audience. Is it possible to define standard results, that mean analytical or numerical, and to compare the pyLife response to this valid response? That means not to go there and back, but to set it, I guess, to some specific values.
Well, of course, you can do any kind of assertion. So yeah, maybe we just click around a little bit here in this. Do you have these other tests? Oh, there were the. Let me just check some other tests. The equivalence stress we said. Equivalence stress, for example, here. Here we have the equivalence stress. So what we are doing here, this is a little bit also a little bit advanced. So yes, we have this eigenvalue function here that we need for several equivalent stress functions. And so we get here we get these values S11 to S23, and these are the eigenvalues that we expect, and we actually calculated those, I don't know where we got them from. You can calculate it with pencil and paper. So these are several cases. So this is stress tensor, and then the eigenvalues that you would expect. So we have several of them: 1, 2, 3, 4, 5, 6.
Yeah, but you can also do that, for example, for a whole FE mesh. If you trust, for example, in this calculation of von Mises stresses or the eigenvalues, the invariants, then you can use that and you can test against millions of nodes if you like to.
That's what you see here.
But you can do it.
Yeah, that's what you see. What you see here. So we have individual scalar values for the stress tensor, and then the eigenvalue is supposed to be a list of 3 numbers. Then here the eigenvalue, the stress values, the stress tensor is actually not one value, but it's a list with one value, and then the expected result is supposed to be is supposed to be a list with one list in it. Then here we have an actual list, so we actually multiplied them by 10, all of these, and then these are multiplied by 10 with respect to those here. So this is now 2 stress tensors, so we get 2 eigenvalue lists. And this is how PyTest is doing this. So we have this decorator here. We say, okay, this test function has the following parameters, S11 to S26, S23, and the eigenvalue check. And these are the parameters. So S11, S22, S23, and so on until here. That's the eigenvalue check value. And we have of these parameter sets, we have several. And now when we run this test, Daniel, can I run this test here somewhere? Yeah. Is it? Oh, here. Then it actually runs this test 6 times. Because there's 6 input configurations, and it tests all of them. And they are all 6 are green. So what happens here? We get these as parameters as we have defined here, and then so we calculate the eigenvalues, and then we use the NumPy test facility if these resulting eigenvalues are all close to what we expect in these eigenvalue checks. And furthermore, the shape of the array must be the same shape as this list that we get. So that's the test we are doing here. And there you can do all kinds of assertions. Here we have actually done it. We have an input, and we expect an output that we have thought out somehow, and we check if the result is matches the expected output. And here, yeah, it's a different variant. Oh, okay. Here, this is something we do not only always test this the happy path. We also sometimes test if something is failing. This here is not ideal because this tests just an assertion error. Actually, it also should test for the error message. Because that's there's room for improvement, but yeah. And then there's other tests here for signed trace and so on. So there's a whole bunch of tests, and yeah, it's that's some comment that sometimes is raised. You will have more lines of code for the tests than for the actual code, and that's true. That's I don't say it's a target value. But it's out of experience. You always have like 2 times to 3 times more lines of code for the tests than for the actual function. That's always that's where you usually end up if you have a good test coverage. And also, what another experience is you have more or less 1 test per 3 lines of production code. That's also, it's not something that we aim at, but it's something that turns out to be that way you end up. And yeah, that makes us quite confident that whenever something is, Daniel is developing here, and immediately the tests will beat his fingers. And there's also here in VS Code, you can run the tests individually. You can run the tests for one module. There's also people who run the tests all the time. They have a test runner in the background, and they will all of a sudden, when it realizes something has changed, so it runs automatically the tests, and then then they get a notification you have broken something. There's also people who are doing, this is also quite an interesting way of working. You write a test, or well, you write some production code, and when the test fails, it will revert all the changes that you've done automatically. So if once you save something and you made a mistake, everything will be reverted. And that's well, I've not tried that because it sounds really rude, but the people who are doing that say, yeah, that forces me to go small steps. Because I really do a tiny change that I can remember. When it's thrown away, then it's not that much of a loss. But I'm forced to do tiny steps that I still can understand. I'm not just programming and then run the tests and they are failing somewhere. It's really forcing you to do tiny steps. So there's in this test-driven development community, there's all kinds of let's say schools. And that's yeah, it's quite interesting. So this is how we do it. We usually for these more mathematical things, we usually have like examples. For the rainflow counters, for example, we have taken from books or from lecture notes examples, and that has an advantage when you take from like the Haibach book. You can reference that. You can say, okay, this is the example that Haibach's mentioned in his book, so we are sure that pyLife is handling that correctly or according to the book. And yeah, so that's how these tests work. And so then later on, maybe I can show this also. So later on, we are here on GitHub. We have this GitHub folder, and in the GitHub folder we are defining workflows. And there's one workflow is the PyTest, and what it does, it says, okay, every time when someone pushes to master, or when someone files a pull request to master or development branch, then we do the following. We have a matrix. Where's the matrix? Actually, the matrix here. It's 2 operating systems, and it's 4 Python versions. And we do the following steps. So we check out the code and so on and so on. We are installing a Python version here. That's the setup Python action. So these are actually actions that you can call, external ones. And we set up a Python version of this matrix, and then we install all the dependencies. So we with pip we install pyLife itself along with the testing facilities, and then we run PyTest as I've shown earlier from the command line. And then then we use the demos. Remember, we have these demos here in the setup config. Where's the setup config gone? So away. Setup config. Here we go. So remember, we have the demos here. That's these demos at these notebooks that we are demo notebooks that we are testing. They are run in a second step. So with this M here, we can say we want to run the tests marked as demos. And yeah, so then what happens is we have these GitHub actions, and every time when someone files a pull request, then maybe I go to pull requests here. Okay, I think I showed this yesterday and it did not work really. So what happens when someone files a pull request? Now it's don't see it anymore. Maybe I go to another project like Pandas. They have a way more impressive test suite than we have, than we do. They so let's go to the GitHub actions. Oh no, I go to pull requests. So they have other figures than we do. 3.45K issues. a couple of hundred pull requests. Here's a pull request. And this pull request here, the test suite is still running. So there's a couple of tests. These have already run successfully. This one is still running, and you can actually watch it. So there's they have lots of tests here, different Windows versions, different Mac OS, and so on. And so also 32-bit. That's also interesting. And so the tests are still running here, and you can also follow the output here. So that's what you call CI/CD. We had this on one slide. CI means continuous integration. That's makes sure that your software continuously is integratable, and continuous CD means continuous deployment. And that this continuous deployment community is also there are also these radical ones who say that you should be ready to deploy every day. That's because you should take everything in small steps, and this in some contexts this might be also possible. But also, well, we try to be deployable as soon as possible. So we failed at this with the nonlinear, because we kept this branch in some non-deployable state for a year and then tried to merge it, and it made an awful lot of work, which is still not completely finished. So and that's what CI/CD means: do things in small steps and be ready to deploy like every 2 weeks or something. So you should not work on something for more than 2 weeks before you can actually say, okay, you could deploy it. And yes, for example, if you write a web page, you can say, okay, you cannot log in because I have not done the login feature yet, but you can log out, and it's ready to deploy. What we have done is ready to deploy. It's not, there are features missing, but the ones that are ready are deployable. That's CI/CD. And so for this CI/CD stuff, you use these kinds of actions here. Okay, in the meantime, this test has actually run through, so that's that seems to be successful. And when we now go back to the pull request, there's still one not completed, or maybe I reload. Okay, all checks have passed, and then it could in theory be merged. And they have all kinds of deployments of tests. And we also use that in pyLife for deployment. So when I tag a release, then the GitHub action automatically packages it and deploys it to PyPI. Okay, so back to so that's this whole way of test thinking. You are making the unit tests. You are making like integration tests. For integration tests, you have to a little bit think about how you set them up, because that really depends on what you need for integration tests. For example, what you can't do on the GitHub action, well, you can do it, but it takes extra effort, is when you, for example, need Abacus. You cannot use Abacus on the GitHub action because you need a license. In theory, what you could do is so these actions here, that we see here, they run on GitHub hardware. So GitHub has a computing center where they have the hardware, and they fire up virtual machines and they run the tests. But they only have access to software that's available in open source. So if you're plain open source, you can do that. Once you need specialized software that's not available in open source, what you can do is you can install it on your computer, and you can tell your computer, please listen to what GitHub is saying to you. And then GitHub is talking to your computer, and your computer will perform these these actions. So that's also possible. And sometimes people do that for also for specialized hardware. They are actually doing that in their labs. They have microcontrollers which are triggered by another computer, and then with some sensors or whatever, they check if the microcontroller has done the job correctly. So there's a lot of things are done, and that's unit testing, integration testing, CI/CD.
So, but we if you like to collaborate, we just expect unit tests from
that's
your code. And I think you can start really with easy unit tests, and then in collaboration with us or with colleagues which have some more experience on that.
Yeah, that's because
for
the simple reason that pyLife is a package. So this is only thinking of architecture. It's only a part of your building, and so we don't do any architectural tests if the whole building works. This would be an integration test. We cannot test this with someone who's only delivering the front door. Then it doesn't make sense to test the whole building. It's just we need to check if the handle and the lock works. That's unit tests. So that's what we need when people are contributing to pyLife. And you can check out the test suite that we have, how we do things, and also the PyTest. The PyTest package is also quite well documented, also with these kinds of fixtures, and we can also support you when you have questions.
Okay, I think it's time for the last break. Should take 2 hours now. Should we come together again at 3 p.m.? Yeah, and then maybe we can make a short wrap up and close this 2-day session. Yeah, that's okay. Okay, great. See you. Okay. We will do it in the following way. First of all, we will have a wrap up, and you're really recommended to give us any feedback. Speak open, speak loud. Yeah, say what we could do better in a different way, or what you like or dislike the last 2 days. How you like to contribute in the future with us, whatever you want to quote or ask, feel free to do so. And after the wrap up, we will give a short introduction, which is not directly connected to pyLife, but to one functionality of Pandas, which is also used by pyLife. That is called the broadcasting option. Yeah, and there's broadcasting option which helps you to deal with different dimension of arrays, tables, and so on. But first, or let's say it's the last, not the first, the last official topic from the last 2 days will be this wrap up. And do you want to start, or should I start?
Yeah, start.
I can start. Okay. So it was really interesting. The best thing was the coffee. No. So that's really good to be here for us. So we got a lot of feedbacks, really good questions. Also, in case of what we are not doing or we do not plan to implement and why. There was what was most impressive for me was that a lot of attendees has tried out to run the Jupyter notebooks, try out to work, maybe for the first time with Jupyter or with Visual Studio Code. That's really good. That's something we do not see so often inside Bosch. So appreciate that. It's great job from your side. And we get also, of course, it's quite difficult to communicate both or with the online participants and with the live participants. But at least for all who are sitting here, thanks for this 2 days, for joining the session, to give us feedback and to try pyLife out.
Yeah, to also to me, it was a lot of fun being here, presenting, getting also feedback from you, getting all these questions, sometimes also being challenged. We have a couple of takeaways that we now know that we need to improve, especially with respect to documentation, and yeah, so we will tackle this the beginning of the next year. So now it's first Christmas. So it's a little bit this effect when you're going to a conference. You immediately after the conference on the way home, you have a lot of ideas, a lot of momentum, but it's actually not that trivial to actually get this over to real work. So we hope that this will work out. This is also meant for you guys. We said a couple of times you can post an issue, you can post in the discussion, and we really mean it. So please don't hesitate to bring in your ideas or things that you think need to be improved. And yeah, as I said, there's lots of options that we in some way, one way or the other, can collaborate.
Okay, before I give over to Jan, first of all, thank you, Jan, very much. So
Yeah,
to
thank you.
invite us, not only to invite us, but also to prepare everything, to invite the attendees. Was a really great job. Thank you once again.
Yeah, thank you for initiating this.
Yeah, I would like to thank Daniel and Johannes for coming, because of, for me, and I guess also for you, it's kind of opening eyes to something which exists, which we can use, which we are not used to do. Yeah, and also to let us think what could be changed also in our university. By the way, how to proceed, where to look. Yeah. I would like to keep the momentum. Yeah. So I guess we will try to push a bit further on during January, February, not before Christmas for sure. I would like also to thank Tomáš Vavra because of the work he
Yeah,
done.
that was really a great job.
For all this online transmission and so on. That's really good. And I have a quite nice announcement, because of the first day video is already prepared. And during this weekend, we should have also the second day. So I guess before Christmas, I guess next week, I will be able to upload it to YouTube and get to you the links to the video, so that you can return to this meeting forever, showing it to your wives, girlfriends, children, and so on. So that really has some momentum on. What I a bit still lack here is to get pyLife out of Bosch borders. For me, it's hard to a bit understand, because for me this is a new experience with open source programming. I gave Practic as a freeware, so everybody who wanted to download it had to register for nothing, but still he or she should be there, and I get some track. They could fill in very strange items. So I had there a lot of people who are born in the year 0, and so on. But still I had some track. Yeah. Here we do not know what's going on, who is using it, in which silly way. So for me would be also an interesting output to think about a pyLife meeting. Sometime in future, to have it again inside or on site, online, to make maybe that hackathon. Yeah, that could be something which can we cooperate on. And also I'm quite ready to advertise pyLife in my networks, because of there is a lot of academicians there involved, and I think this belongs to academia, this belongs to school. That's good that Bosch is doing that. Yeah. Anyway, but we need to get more momentum, more active programmers, and as I told you in the very beginning, if my students or any other students have to do some kind of programming, why not to preserve it forever. Yeah, Maxim over there. Yeah, raise your hand. Yeah. He spent a terrible time in trying to understand how methods dealing with conversion of elastic stresses to elastic plastic in Neuber-like methods, how they work in multi-axial domain, what to improve there. And he was trying to understand from different papers, different methods. And the bad experience he gained was that nearly no method which was described in a specific way in International Journal of Fatigue or any other journal, he was able to get into a running code which would lead him to the same results as those which are published. And that's common in research. Yeah, so we have very many different implementations. Author implements something. Even he can introduce errors which make his work running, and this is presented in International Journal of Fatigue, and nobody knows how he made that. Yeah. He tried to contact the different people around the world. How it works, how it comes that I cannot get the same results as you. Could you help me with that? And usually nothing happened. Yeah, so by getting that into a running code, which is accessible to anybody in open source program, that's a solution. So there's a future for you all here. So thanks. This is for you. Any other experience?
Mic drop.
I will check the online audience. There is nothing more from online audience. So, if I understood it well, you propose now to close the session, and only those, say, adventurers who want to know about broadcasting should stay. Am I right?
Because you mentioned a pyLife conference or workshop, something like that, the near future. So we are talking since 1 year about that topic, I think, around. We have plans to do something like that. We could do it at Bosch, but we want to have this in an open source manner in a way. And it would be great to have that on a university, for example, or maybe not really at a Bosch location. Because, of course, we are from Bosch and we are maybe the main contributors at Bosch, but pyLife is not only a Bosch thing, it's an open source thing. And we should live this open source idea.
I would continue here because of, Prague is quite a cheap country unless you go to a Greek restaurant. So, there would be a definitely solution. We have experience with organizing such events. We would be quite honored to establish something like that here. Yeah. Feel invited.
Stay in contact.
Okay.
Thanks once again. And if you want to stay and listen to Johannes about broadcasting, which is really interesting.
Well, it's... And nobody wants to comment on the session. Come on. That's yeah, well, it's probably not that completely long anyway, what I'm going to show. So now let's check in the documentation so that we know where we are. So it's in the pyLife user guide. There's a section on this here at the bottom, the signal broadcaster, and so what this is about. So we have again this Wöhler curve data that we have already seen yesterday. So we can use this cycle function to actually get this the cycles for a certain load concerning this Wöhler function. We just call the method with a scalar value, and then we get a scalar result back. It comes in a zero-dimensional array, but it's still a scalar. And we also can, with the same function here, we can set up this load as a pandas series of like, let's say, different elements. Like when we have a fem mesh, so this can be a really small fem mesh with 4 elements. And then when we feed in this like fem mesh, it could also be a 4 million element fem mesh. Then we get the cycles for every element ID. So we have, this is a pandas series. It has an index. This index is the same index as here. And so yes, we have for every element, we have like the cycles, the cycle to failure. And yeah, so here we can also bring this one step further. So for example, we have here, let's say we have a material gradients. So we have for every element of our mesh, we define a different Wöhler curve. So we have different fatigue limits in load direction. Everything else in the Wöhler curve is identical, but there's just as an example different limits in load direction. And so we have actually here this becomes a pandas data frame. So we have again element ID as index, and we have as the columns we have the different parameters of the Wöhler curve. And then we can access this with the Wöhler accessor and call cycles. And then we have here for every element the expected cycles. So for example, for the element 1, we can just check. Element 1 has 370 fatigue limit, and so probably for element 1 here, element 1 is the only one below the fatigue limit, and that's why we get this infinite value here. So now we actually applied not only a load mesh, so that we have from like finite element analysis to a material, but we also have mapped different materials, like could be a hardness gradient that we somehow simulated from case hardening, from some heat treatment simulation. So we map to every element a different Wöhler curve, and then we can accordingly measure the calculate the cycles. So now let's go even one step further. So we have here like amplitude scenarios, like load profiles or whatever. So we have here different load profiles. They have only one load amplitude, but there's different ones of them. It looks quite similar like this here. So it's here, it says amplitude, it has 4 values, and it has an index, and the index has a name like element ID. And here we have, well, actually exactly the same thing, but the index is named a scenario, so not element ID. So it's the same thing as here. It's even the same values. And when we do this now, so we do exactly the same thing as we have done before. We have here, we have applied these this amplitude to the Wöhler curve, and we got these for these 4 elements the cycles. Here it's different. Here we get for every element ID for every scenario a different result. Because the name here is different, so the name scenario is different from the name element ID. So the broadcaster thinks, okay, that's 2 different things. I'm not allowed to actually apply one to the other. It's we have element IDs and we have load scenarios, so it's not the same thing. So I cannot just join them together, even if they have the same indexes, even if they are 1 to 4, it's different things. I need to cross product those, and that's what the broadcaster is basically doing. So, for example, when you have so you can have different materials in every element. You can also have different load cases in every or load profiles in every element, and you can combine them together. And the broadcaster will always do what makes sense. So either it will combine them when the index names are the same, then it will assume that it can combine them. And if not, it will well blow the whole structure in this cross-product way. Are there questions so far? Is this understandable or completely? That's
It's common in Python or
the term broadcasting.
yeah.
Yeah, that's coming from NumPy. So NumPy is they actually invented the term broadcasting for that. That when you have a NumPy array and you say, maybe I can just demonstrate real quickly here. Let's set up a new notebook quickly. So when I import NumPy, and now I say, okay, well, I have an array. So A equals NumPy array, and I say, well, 1, 2, 3, 4, 5. So that's my array. Looks like this. And then when I say A plus 2, I get another array, and this A plus 2 is actually is just added to all these values here. Can also say A times 2. Then yes, and the same is when I have an array B, like B. Let's say it's 10, 11, 12, 13. 14. I need, yeah, that's enough. Then this array, no, sorry, I've forgotten. So B looks like this, and I say A plus B. Then it also adds these element-wise. And so interesting thing is what happens when I drop one value here, like let's drop the 10. So then I will get an error message because it cannot broadcast this to the other. So that's where the term broadcast is coming from. And yeah, that was already quite powerful in NumPy. But what it cannot do is it does not have this concept of column names and indexes and index names, and so it does not it doesn't have semantics. It just says, okay, if the dimensions somehow fit, it will broadcast. It will combine. It will combine the. It's also when you have a multiple array, it will broadcast the one dimension to the other as soon as they are somehow compatible. For example, here this 0 dimension here, the 2 is compatible with this, and it just will broadcast. If it makes sense, it's not. We cannot determine because you don't have index names. The index names give you an idea if it makes sense or not to actually just multiply those. Question? Okay, so this is this here. Yeah, and you can. What's this here? This is another example where we have everything in one series. Actually, this is uncommon. Yeah, so this is this multi-dimensional index where we have here the scenario and the load in a multi-dimensional structure, and yeah, the broadcaster then will take care of doing the right thing. Oh yeah, this is the amplitude scenarios. Here we had an amplitude scenario only for the scenario. Here we had an amplitude only for one scenario each. Above we had an amplitude for each element, and here we have it as a multi-dimensional structure. So here we have it actually as a for every scenario, for every element, we have a different amplitude, and yeah, the broadcaster then also does the right thing. So it sees, okay, scenario, I must join the element ID from here with the element ID from the Wöhler curve, and then it will fit. Okay, so and that's what is so charming about that. You have in all these cases, no matter if you deal with just one scalar value or if you deal with a complex mesh in both and even combined with some load scenarios, it's just this line of code which finally calculates the cycles. And that's what I meant. So this cycle function here is completely easy because it doesn't know if it deals with meshes or with just scalar values. So when you program it, we don't have to think about it that much. And but the broadcaster is taking care of that. And then here, how to use the broadcaster. There's this here. This is still to be written. So on the way here, I've been thinking about what would be a good example to actually show how you use the broadcaster directly. And I was looking out of the window of the train and thinking what might be a good example. And I came up with one example which I then have shortly implemented. And this example is called the Bridges of Prague. And so we think of seasonal flood events of the river Vltava, and what this will do to the bridges of Prague. So we have one series in which we have the water levels of different flood events, like one in spring, one in summer, one in autumn, and one in winter. And we have for every bridge of Prague here, we have like a sensitivity index, how we need to multiply the global water level in order to get their exposure to damage. So it's from an engineering point of view, it's maybe overly simplistic. I just want to show how this broadcasting here works. And now let's say in our model we need to multiply these sensitivities to the global water level. So what will happen? Let me just so these are the flood events. Look like this. These are of these bridges the sensitivity indexes, and when you multiply them, it doesn't work because Pandas doesn't know which of those to multiply with which, because the indexes are completely different. And so what you can do is you can use the broadcaster. So I'm instantiating the broadcaster with like the flood events. And I broadcast this to the sensitivities. And what I get is actually two objects. It's a tuple, so there's one object here, the sensitivity, and another object here, the water level. And now the indexes of these two are identical. We always have this this season or event, a flood event column, and we have for each event we have the bridges in the sensitivity series and in the flood event series. So that's what we call mapping. So we map one to the other, and this results usually in a way bigger data structure, because that's the cross product. And then we can actually do that. So we let me just put them into a variable flood. So I name them differently. Now it's first is what's the first one? Sensitivity. No, water level flood event. Yeah, okay. Sensitivity. I just make flood. Some shorter names. And so when I now multiply sense times flood, then I can actually multiply them. So what has not worked here is now working, because it's multiplying the global water level of all the flood events with the sensitivity of all the bridges. And so now you can assess well the bridge that's most endangered or whatever. And when you now say, okay, but also not only the water level plays a role, but also the dwell time, how long the flood actually is lasting, then we have here in for all the seasons, again the index is the flood event, and they have a dwell time. So this dwell time structure looks like this, and then you can again broadcast these to. Let me broadcast these to which ones? Yeah, also to the what's it called? To the sensitivities maybe. So let me broadcast, or just say dwell, and nothing equals broadcast sensitivities, and then broadcast this to the dwell. And then there's some broadcast. Have I? It's broadcast there. So okay, and then I can actually do dwell times flood times sense, and then I have also the dwell time multiplied to those. And as you see, that this dwell structure here, it has this two-dimensional index, and that's because the index here, this flood event, is the same name as this flood event here. If I name this differently, if I name this, I don't know, somehow differently, and then I broadcast those, then I get what have I done now? Yeah, well, that doesn't work like this, because it's now also two-dimensional. I need to broadcast this to the, let's say, to flood. Dwell time. What dwell time is now? Now I'm getting confused, because here this should actually have this. Maybe I flip those. Oh no, I need actually to output it. Yeah, so it was just has not updated the output. Now it's getting more complex, because I have this flood event here. This is no longer matching. So because I've changed this name here, so now the broadcaster thinks, okay, these spring, summer, autumn, winter are different things than these here, because they have a different column name. So I'm not allowed to treat them as one. So I need to add one more dimension. Yeah, that's what the whole broadcasting is about. And so that's the map part. And then afterwards you can, maybe I correct this again. Let let me just flood event just to get this correct. No, sensitivities. So now it's correct again, and I can again here say dwell times flood times sense, and I get some results. So let me put that into a result value. So the result value looks like this. And now we can aggregate those. So we can now say, okay, which we can group by the flood events and say which one was the most endangered bridge in all the flood events. Like for example, that would be result group by bridges. Yes, sorry, thanks. Bridges, and then we say maximum. No, it's not bridges, it's bridge. And so these are for every bridge. No, this I've done it in the wrong direction. That's for every bridge the most dangerous flood. Now we can also do it in the other direction. So that's no different. No, it's sorry. It was this is for yeah, for all this. Yeah, so the no, that's I have to think how to interpret this. Again, this is only bridges. So that's the most dangerous flood for every bridge, but we unfortunately we don't know which one it was. This information we don't have no longer. We can also here calculate the mean. So that's averages over the flood events, or we can also do sum. Probably doesn't make any sense, but we can do it. And yeah, so that's then the well, maybe it's the damage sum, yeah, for every bridge. So that's what we then call reduce. So we had in the beginning we had the map. So we have different data sources which we somehow map together. We get a huge data set which is multidimensional, and then later on we think of a way how to aggregate it to get actually the result that we want to know, that we then can also with the human brain actually deal with. And that's what the broadcaster is doing. It's not part of Pandas, so we implemented this in pyLife. But yeah, we are thinking of if it actually has to be part of pyLife, if it can be actually in a separate package, because it's not really fatigue related. We needed it in fatigue because it simplifies a lot of things, like dealing with fem meshes and time series and load collectives, but it can also be used in lots of other things. So yeah, we'll see what happens in the future if we maybe talk to the Pandas guys if they want to take it over. I don't know. That's at the moment it's part of pyLife, and so we will whatever happens, we will make sure that it works from within pyLife in the same way. All right, so much about the broadcaster. Are there any questions about that?
It seems there are no questions.
Okay.
So now we understand what broadcasting is. Yeah, great.
Mm-hmm.
If there are no questions to broadcasting, are there any other comments or questions? This is the last call also for online audience. Are there any questions? They are basically slower, yeah. So that's a question if they are able to answer so quickly. But I don't think nobody is asking anything more. It's getting close to Saturday, yeah. So thanks to all of you to join us. Thanks all for all the next work, which I assume all of you will be will be very happy to deliver. Great. And I'm closing this session. And as I told you, I expect next week all the videos should be available on Practic website. Thanks. And thanks again, Daniel and Johannes, for coming and for all these presentations, which are very, very interesting.
All right, and thank you for your interest and all your questions and challenges, and special thanks to Jan for inviting us and organizing us. Yeah, it was really worthwhile coming here, and yeah, I'm really looking forward to further contact, further collaboration.